At the centre of a faraway galaxy sits Holm 15A, a place that holds a black hole so huge that it breaks almost everything we thought we understood about gravity. How could something this unbelievably large still exist today? In this video, we'll explore the story behind the heaviest black hole ever found in the part of the universe we can see. Before we start, like the video and subscribe to our channel, and let us know in the comments below where in the world you're watching from. We're always eager to hear where our viewers are tuning in from. The universe has spent countless billions of years quietly teaching anyone who pays attention a strange but beautiful lesson. It is that the things that shine the brightest are not always the most powerful, and the most powerful things do not always rush to be seen. Instead, they sit in perfect calm, wrapped in silence, doing their work without light, without noise, without even the faintest desire to be noticed. It is almost as if the universe whispers to us, reminding us that the greatest forces are sometimes the ones that look like nothing at all. And if we listen carefully, we begin to understand that true power is often found in stillness. Far across the deep southern sky, in a direction most people never think to look, lies something so large that our minds almost refuse to accept it. It is not close to us. In fact, it rests nearly 700 million light-years from Earth, a distance so huge that even light, the fastest thing in existence, would need hundreds of millions of years to get here. And out there in the dark ocean of space sits a structure greater than any single galaxy, greater even than collections of galaxies. It is something like a cosmic nation, an entire environment built from gravity itself. Astronomers call this vast region Abel 85. Thinking about it is like imagining an ocean so wide that continents float on it like drifting stones. Hundreds of galaxies move inside this enormous gravitational landscape, the same way ancient landmasses once drifted slowly across Earth's oceans. They do not hurry. They glide in silence, carried along by a web of gravity that spreads through space like an invisible net. But the strange thing about this gravitational net is that most of it cannot be seen. The galaxies inside Abel 85 sparkle with stars, but the weight of the cluster does not come from the light we can see. Almost 90% of its entire mass is dark matter, a mysterious form of matter that does not shine, does not glow, and does not interact with light at all. Yet it shapes everything. It is the spine of the cluster, a silent framework holding the entire structure together. Within this enormous gathering of galaxies, the space between them is filled with superheated gas. And when we say hot, we do not mean the heat of a summer day or a burning fire. The gas is heated to tens of millions of degrees, so hot that it gives off a faint ghost-like glow in the form of X-rays, creating a misty atmosphere around the cluster. For distances stretching hundreds of millions of light-years, this is the environment. Drifting galaxies, boiling clouds of gas, the pull of dark matter, and the slow grinding of objects that have existed since the earliest ages of the universe. It is a place where collisions do not just happen, but are guaranteed. Because when you have hundreds of galaxies packed into one region like this, each one moving under the pull of all the others, it is only a matter of time before paths cross. And in a realm where time is counted not in centuries or even millions of years, but in enormous cosmic ages, every galaxy eventually meets its neighbours. Collisions become stories written into the stars. Yet, in all of this noise and light and heat, with galaxies drifting, stars burning and gas glowing, one object sits at the centre of Abel 85 unlike anything else. It does not shine brightest. It does not flare. It does not call out for notice. Instead, it waits in silence, as if confidence alone is enough to declare its importance. This central object is the brightest cluster galaxy of Abel 85, known as Holm 15A. It is not like the graceful spiral galaxies we often see in pictures, the ones with curling arms and bright glowing centres. It is a giant elliptical galaxy, old and faded and stretched wide, its light spread thin across space. It glows with a reddish colour, the colour of ancient stars that have used up most of their fuel. When seen from Earth through a telescope, Holm 15A does not impress anyone at first glance. It looks like a soft smudge, a blur, almost like a foggy fingerprint against the darkness, so smooth that it seems to dissolve into the background behind it. It looks gentle, unassuming, unremarkable, But this softness is nothing more than a disguise. Beneath this calm glow lies one of the strangest and most extreme environments the universe has ever created. Holm 15. A is enormous, but its size is not the kind of size we expect from a galaxy. Spiral galaxies wear their size proudly, with arms that stretch outward like bright whirling rivers of stars. Holm 15A, however, is big in a different and unsettling way. It is wide, stretched, and strangely hollow. Instead of growing brighter and denser at its centre the way most galaxies do, its light grows dimmer as one moves inward. Its heart is not a shining core of stars but a ghostly empty space, a region so vast and so hollow that it challenges everything astronomers once believed about how galaxies should form and look. In most galaxies, including our own Milky Way, stars gather toward the centre, becoming packed tightly together in a glowing sphere. But Holm 15 breaks this rule completely. As you move toward its centre, instead of seeing more stars, you see fewer. The light fades, then fades again, then seems to fall away entirely until you're left with a dark, empty region so large that entire galaxies could fit inside it. If our Milky Way, with all its stars, planets, gas clouds, spiral arms, and central bulge, were placed inside the hollow core of Holm 15A, it would fit comfortably with room to spare. That is how huge the empty centre is. This emptiness did not appear suddenly. It is the scar of a violent and complicated history, a memory carved into the galaxy over billions of years. In the far past, Holm 15A was not a single galaxy. It was many. Abel 85 is a region dense enough that galaxies are always colliding. They drift closer and closer over millions and billions of years, lose energy, fall inward, and eventually merge together. Each time two galaxies collide, their stars blend, their gas mixes, and a new, larger galaxy is born. Over time, Holm 15. A became something like a collector of galaxies. One after another, smaller galaxies spiraled inward, falling into the central region of the cluster and merging into a single growing giant. And with each of these mergers came another hidden ingredient: black holes. Every major galaxy carries a supermassive black hole at its centre, a gravitational anchor that shapes how the stars around it behave. When two galaxies merge, their black holes sink slowly toward the centre of the newly formed system. What begins as two separate giants eventually becomes a pair locked together in orbit, creating what astronomers call a binary black hole, and these binaries are incredibly powerful. When two supermassive black holes orbit each other, their combined gravity becomes something like a cosmic slingshot. Stars that wander too close are not gently pushed aside, they are hurled outward with unimaginable force. This process carves out the galaxy's centre, flinging stars away and leaving behind an ever-growing empty region. And this did not happen just once inside Holm 15A. According to many astronomers, Holm 15E experienced more than 10 major collisions over its lifetime. Each collision created another binary black hole. Each binary carved away more stars. Each event widened and deepened the hollow core. The heart of the galaxy became a workshop of gravity, a place where the universe used violent motion to sculpt emptiness. Today, Holm 15. A stands as a kind of fossil of this process. Its outer regions glow with countless old reddish stars, stars that have survived the chaotic mergers. Its inner region is a vast, ghostly space where stars once lived but were thrown out long ago. The galaxy is quiet now, with no bright blue stars, no newborn clusters, no swirling dust lanes. Everything inside it is old, ancient and tired, a population of stars that has watched billions of years pass. But even this unbelievable core is only half of the truth. The real treasure of Holm 15. A lies even deeper, in a place no telescope can clearly see. In the very centre of its hollow heart sits something so massive, so heavy, so beyond normal human understanding that even astronomers struggle to describe it. It is a supermassive black hole weighing tens of billions of times more than our Sun. The earliest rough measurement made in the year 2019 suggested that it might weigh around 40 billion solar masses. Later studies corrected this number and pointed toward a mass of roughly 22 billion solar masses. Even using this smaller number, this black hole ranks among the heaviest ever measured directly in the universe we can observe. A black hole of this astonishing weight bends space in a way that ordinary black holes cannot. Its gravitational pull reaches out across thousands of light years, stars orbiting near the centre of Holm 15. They move unbelievably fast, hundreds of kilometres every second, far too fast for their speed to be explained by starlight alone. Their movement reveals the presence of an invisible anchor, a massive object pulling everything toward it, and yet this enormous black hole sleeps. It is nothing like the bright quasars that lit up the universe in ancient times, quasars powered by black holes swallowing matter so quickly that they glowed brighter than entire galaxies. Holm 15, A's black hole is silent. It has almost nothing around it to eat, and because it is not consuming large amounts of gas or stars, it produces no bright swirling disk, no jets of energy shooting across the sky, no violent flashes of radiation. In a universe where almost everything seems to shout for attention, where stars explode in bright bursts, where jets of energy shoot across unimaginable distances, and where flares rise and fade like cosmic fireworks, there exists one place that rules through complete quiet. It is a silence so deep and so steady that it almost feels alive. But this silence is not a sign of weakness. It is not a sign of a dying object running out of power. Instead, it is a perfect balance, a calm state that has taken countless billions of years to form. At the centre of the giant cluster known as Abel 85 sits a galaxy called Holm 15A, and at the heart of that galaxy lies a black hole unlike almost anything else we know. The gas in Abel 85 is far too hot to cool down enough to drift inward toward the black hole, and the colder gas that once filled the galaxy was swallowed or burned away an extremely long time ago, back when the universe was much younger and more chaotic. With nothing left to feed on, the black hole has entered a kind of peaceful stillness. It does not need to blaze like a quasar or roar like a violent accretion disk. It simply rests, an enormous well of gravity so deep that it binds the entire galaxy together without producing even a whisper of light. It sits there like a titan sleeping at the centre of creation, a giant engine that has turned itself off, a gravitational heart with no shining pulse. This is the strange and almost eerie paradox at the core of Holm 15A. It is one of the most powerful objects for an entire cluster of galaxies, yet to the eye it is nearly invisible. It is a black hole so incredibly heavy that it could swallow entire solar systems as easily as a person might breathe. Its presence is so dominant, so overwhelming, that it shapes the paths of stars many thousands of light years away. And yet, despite its unbelievable size, it glows with less light than a lonely star that is reaching the end of its life. The universe has a habit of hiding its greatest extremes right in front of us, waiting for the patient observer to notice. Holm 15A is one of those reminders. It is a galaxy built from long ago collisions, stripped of the bright young stars that once filled it, hollowed out by the actions of black holes that spiraled together, and finally brought into a calm state that has lasted for billions upon billions of years. Now it drifts in the centre of Abel 85 like a fossil left over from ancient cosmic violence, a faint ember surrounded by the quiet memory of everything it once consumed. But when we look at the core of this galaxy, when we see the hollow space, the strange emptiness, the deep quiet that sits where so many stars should be, we are faced with questions that pull us backward through time. What force could carve out such a huge cavity? How does gravity manage to fling stars outward on a scale so enormous that the hollow stretches for tens of thousands of light years? What kind of history could shape something so big, so empty and so quiet? To understand this, we must step back into the earlier universe, into an age when galaxies collided more often, when their central black holes moved toward one another in slow spirals, forming pairs known as binary black holes. These pairs danced together through space, tightening their orbit and throwing stars outward like stones launched from a slingshot. Each collision between galaxies left a deep scar, a permanent mark written into the structure of the survivors. Each merge of black holes released energy and motion strong enough to reshape an entire galactic core. It is through these violent meetings, these long cosmic dances, these powerful gravitational slingshots that something like Holm 15A could be formed. A hollow giant, a galaxy with a missing heart, a place where the past is written in empty space rather than in light. The story of Holm 15. cannot be understood without first gazing at the immense, sprawling cosmic city in which it resides. The story of Holm 15 cannot be understood without first gazing at the immense, sprawling cosmic city in which it resides, the galaxy cluster known as Abel 85. This is no ordinary cluster, no small gathering of galaxies held together by gravity. Abel 85 is a titanic congregation of thousands of galaxies, a dense and restless metropolis of stars, dust, gas, and dark matter that stretches across millions of light years. To picture it, imagine a space so vast that if our entire Milky Way galaxy were a tiny grain of sand, it would be almost invisible amidst the scale of the cluster. And yet, every single one of those grains of sand, every star, every black hole, every atom of gas is caught in a gravitational dance orchestrated over billions of years. Abel 85 is ancient, older than most of the stars that shine within it, a relic of the universe's own youth. Its formation began when the universe was still very young, just a few billion years after the Big Bang, when matter had begun to clump together under gravity's inexorable pull. Vast clouds of hydrogen and helium, the primordial gas left over from the birth of the universe, slowly gathered, colliding and merging in a grand cosmic ballet. Galaxies were born in these collisions, their stars igniting in brilliant bursts of light, scattering heavy elements into the surrounding space, setting the stage for planets, life, and ultimately the universe as we know it. Holm 15A, the galaxy we now consider the master of Abel 85, did not emerge in isolation. Its identity, its size, its structure, and even the supermassive black hole at its heart were shaped by the turbulent, energetic environment of this enormous cluster. To understand this galaxy is to understand the cluster itself, because Abel 85 is not just a background, it is the very soil from which Holm 15A grew. The cluster is dominated by dark matter, a mysterious substance that makes up the vast majority of its mass. Dark matter does not emit or absorb light, and we cannot see it directly, but its gravity sculpts the motion of galaxies, guides the flow of gas, and forms the deep wells into which ordinary matter falls. Without the invisible scaffolding of dark matter, Holm 15A would not have achieved its colossal size, and its core would never have become home to a black hole that outweighs entire galaxies. The galaxies within Abel 85 are not peaceful neighbours. They interact, collide, and merge in a slow, yet relentless cosmic struggle. Over billions of years, smaller galaxies fall into the cluster, drawn inexorably toward its centre. Many are torn apart by tidal forces, their stars strewn across space, their gas ripped away in immense streams, adding to the cluster's diffuse intracluster medium, a vast ocean of hot, X-ray emitting gas that pervades the space between galaxies. Holm 15. A, positioned near the cluster's heart, has been the ultimate recipient of these mergers. Each time a galaxy fell into its gravitational grip, Holm 15 absorbed its mass, its stars, its gas, and occasionally its own central black hole. These accretions did not happen in sudden bursts, but over millions, then billions of years, in a continuous process of growth, making Holm 15 the enormous and dominant galaxy we observe today. The environment of Abel 85 also plays a crucial role in shaping the galaxy's structure. The cluster is a violent place. Galaxies move through it at hundreds to over 1,000 kilometers per second. As they do, the gas within them collides with the intracluster medium, stripping away the galaxy's own supply of gas and halting star formation in a process called ram pressure stripping. This is one reason why Holm 15A, despite its immense mass and size, has ceased forming new stars. Its environment has starved it of the raw material needed to forge new generations of stars, leaving it as a red and quiet giant, its light dominated by old stars that formed billions of years ago. The gravitational forces at the cluster's centre are extraordinary. Holm 15 sits in a basin carved out by the combined gravity of the cluster and the enormous dark matter halo that surrounds it. This gravitational well is so deep that any galaxy straying too close is inevitably drawn inward, merging with the central giant. Over time, this process has created a galaxy with a remarkably smooth, extended core. The light from Holm 15A is not sharply concentrated, as in smaller galaxies, but spreads out in a gentle, almost ethereal gradient that reflects its tumultuous history of mergers and the overwhelming influence of gravity. At the very centre of Holm 15A lies a supermassive black hole unlike any other. Its mass is staggering, more than 20 billion times the mass of our Sun. To imagine such a black hole is almost beyond comprehension. It is a singularity so immense that it dominates the gravitational landscape of its host galaxy, influencing the motion of stars tens of thousands of light years away. Its growth is closely tied to the environment of Abel 85, every galaxy swallowed by Holm 15, brought with it its own central black hole, some smaller, some more massive. These black holes spiraled inward, merged, and contributed to the growth of the behemoth at the heart of the galaxy. The process was slow and unrelenting, a cosmic accumulation of mass guided by the cluster's invisible hand. The intracluster medium of Abel 85, the hot gas filling the space between galaxies, also shaped Holm 15A's evolution. This gas, reaching temperatures of tens of millions of degrees, radiates in X-rays and can cool and fall into galaxies, feeding star formation or the central black hole. In Holm 15A, much of this gas has been captured over billions of years, fueling the black hole's growth while leaving little behind for new stars to form. The galaxy has become a master of consumption, devouring not just stars, but the very material that could have formed new stars, leaving behind a vast, almost lifeless core punctuated by the quiet glow of ancient stellar populations. Abel 85 itself is dynamic. Its galaxies are in constant motion, colliding, merging, and interacting gravitationally. These motions create shocks in the intracluster medium, stir turbulence in the hot gas, and drive waves that ripple across millions of light years. Holm 15A. A, anchored at the cluster's centre, experiences these influences directly. Its shape and structure are not only the result of its mergers, but also of the gravitational tides, the flows of gas, and the pressure exerted by the cluster's restless medium. Over cosmic timescales, these subtle forces help to smooth out irregularities, creating the vast, gently rounded and enormous galaxy we observe today. Observations of Abel 85 reveal it as a complex, multi-layered structure. Its galaxies are not distributed randomly, but show patterns shaped by gravity and the cosmic web from which they formed. Filaments of dark matter and galaxies feed the cluster, channeling material inward like invisible rivers, sustaining Holm 15A's growth over eons. The cluster's centre, where Holm 15A resides, is a gravitational sink, a place where matter accumulates, and the universe's natural hierarchy asserts itself. In this sense, Holm 15A is both a product and a regulator of its environment. It has grown large because the cluster funneled material to it, but its immense gravity now governs the motions of nearby galaxies, influencing the cluster's evolution in return. The sheer scale of the cluster and its central galaxy is hard to convey. Holm 15 spans hundreds of thousands of light years, more than 10 times the diameter of the Milky Way. Its mass, combined with the dark matter halo of Abel 85, reaches into the trillions of times the mass of our Sun. Every star, every planet, every photon of light in this region is bound in a network of gravitational forces shaped over billions of years. The history of the cluster and its central galaxy is a record of the universe's own history. The slow coalescence of matter, the violent interactions of galaxies, the invisible hand of dark matter, and the quiet accumulation of mass at scales that stretch human imagination. Holm 15. A's present state is a direct reflection of this environment. It is no longer forming stars because its surroundings have been stripped of cold gas. It is no longer growing through dramatic mergers because most nearby galaxies have already been consumed or ejected. Instead, it exists as a quiet, monumental giant, a testament to the cumulative power of gravity and time within Abel 85. Its central black hole continues to sit in silent dominance. Yet the story is not static. Abel 85 continues to evolve. Smaller galaxy groups and individual galaxies still fall into the cluster, some of them destined to be devoured by Holm 15A, adding incrementally to its mass and the mass of its central black hole. The intracluster medium continues to ripple and flow, driven by the motions of galaxies and the cluster's own gravitational dynamics. The cluster is a living, dynamic environment, and Holm 15A is both its master and its child, shaped by its environment even as it shapes the motions and structure of the cluster itself. Understanding Holm 15. without considering a Bell 85 is impossible. The galaxy is not a solitary entity but a product of its surroundings, the result of billions of years of gravitational sculpting, mergers, and interactions with gas, stars, and dark matter. Its enormous size, its smooth and vast core, its lack of star formation, and the presence of the largest black hole known in the universe are all direct consequences of the unique environment provided by a Bell 85. The cluster is the stage, and Holm 15A is the leading actor, performing a role written over billions of years in the silent language of gravity and time. In the vastness of space, clusters like Abel 85 are rare, and galaxies like Holm 15A even rarer. Yet within this cosmic metropolis we can see the processes that shape the universe at its larger scales. The cluster teaches us that galaxies do not exist in isolation. They are shaped by their surroundings, moulded by interactions, and defined by the flows of matter and the pull of gravity over incomprehensible spans of time. Holm 15. A is a record of these processes, an immense archive written in stars, gas, and dark matter, a monument to the power of the universe's invisible hand. Through studying Abel 85 and its central galaxy, we gain insight not only into the life of one extraordinary galaxy, but also into the grand narrative of cosmic evolution. We see how matter organizes itself under gravity, how clusters grow and mature, how galaxies collide, merge, and consume one another, and how even the largest structures are subject to the invisible but relentless forces that govern the cosmos. Holm 15A and Abel 85. Together are a story of scale, time, and gravity, a story that stretches across billions of years and millions of light years, inviting us to contemplate the vastness of the universe and the extraordinary processes that have shaped it from its earliest moments to the present day. In the quiet light of this galaxy, the echoes of billions of years of cosmic history can be traced. The stars, though ancient, shine as reminders of the clusters and galaxies that once existed and were incorporated into this colossal system. The diffuse intracluster gas glows faintly in X-rays, carrying with it the energy of violent collisions that occurred long before humans existed on Earth. The dark matter, invisible yet omnipresent, binds the entire cluster together, its presence inferred only through the motion of galaxies and the gravitational lensing of light from distant objects. The huge empty space at the heart of the galaxy called Holm 15A did not appear in one sudden moment, and it was not carved out by one single dramatic event like a cosmic explosion or a monstrous collision. Instead, that vast hollow is the slow and patient result of everything the galaxy has experienced across almost the entire lifetime of the universe. It is a record written not with ink, but with gravity. It is shaped by the long history of collisions, mergers, crashes, brushes, and gravitational dances that reach back to a time when the universe was still young, crowded, noisy, and unbelievably energetic. To even begin to understand the true scale of that history, we have to let our minds travel to a version of the cosmos that is very different from the peaceful, stretched-out universe we see today. We must imagine a cosmos where galaxies were not separated by enormous dark spaces, but lived close to one another, like busy cities pressed together on a world much smaller than ours. Instead of drifting slowly apart, galaxies were constantly rushing toward each other, tugged by gravity with a kind of restless urgency. They were richer in gas, filled with raw material for new stars and bursting with motion on every scale. The early universe was not a quiet, ever-expanding emptiness. It was more like a giant workshop where everything was being built at once. Every direction you looked, something was happening. Something bright, something violent, something chaotic. Clouds of gas collided and collapsed. Stars were born in thick clusters. Galaxies formed, twisted, collided, tore themselves apart and rebuilt again. The whole cosmos was a place where nothing rested. Everything was becoming something larger, something more complex. During those early times, galaxies did not wander alone the way many of them do now. They gathered into clusters the same way rivers eventually join together and pour into a great ocean. Gravity pulled them into deeper and deeper wells, and one of these wells was the growing cluster we now call a Bell 85. Though to follow your instruction, I will write that as Abel 85. Even when the universe was only a fraction of its present age, this cluster was already forming, slowly collecting material from every direction, shaping itself into a gravitational trap into which many galaxies would eventually fall. the small galaxies were the first to be pulled in. They rushed toward the densest region the way leaves are drawn into a whirlpool. As they moved closer, their paths curved. They slowed. They spiraled inward, losing their orbital energy as they interacted with the matter around them. These journeys took hundreds of millions of years, and I will spell that out, hundreds of millions of years. That is longer than the age of the human species, longer than all of human civilization, longer even than the time since the dinosaurs disappeared from Earth. But in the universe, that amount of time is common, and as those long ages passed, the cluster stopped being just a loose gathering of many wandering galaxies. It became a system, something structured, something organized by the invisible, patient hand of gravity. And at the center of that system, one location began to act like a cosmic destination, a place where everything that fell inward eventually ended up. That location was the seed of the giant galaxy that would one day grow into Holm 15A. Mergers between galaxies are nothing like crashes between solid objects on Earth. If two cars collide, metal bends, glass breaks, and the vehicles stop. But galaxies are mostly empty space. Their stars are so far apart that even when two galaxies pass directly through one another, the stars barely ever collide. Instead, galaxies behave more like two ghostly clouds that drift through each other. Their shapes stretch and twist not because they hit, but because gravity pulls them around like soft clay. Every merger is a slow dance, a dance that lasts not minutes or hours, but hundreds of millions of years. First, the faint outer halos of the galaxies touch, like dancers reaching out their arms. Then the disks twist and warp as tidal forces pull on them. The elegant spiral arms bend, stretch, and sometimes tear off entirely. Finally, the central parts, the hearts of the galaxies, begin to spiral toward one another. The stars respond to these gravitational changes the way dust responds to powerful winds. They scatter and sweep along arcs that can reach hundreds of thousands of light years in size. So while the stars glide around unharmed, something far more dangerous lies at the center of every large galaxy, a supermassive black hole. Every galaxy of considerable size carries one at its core. It is like a heavy anchor made of pure gravity. So imagine what happens when two galaxies merge. Their two supermassive black holes begin to sink toward each other. They fall as if dropped into thick, invisible water. They lose speed by transferring their energy to the stars around them. Every time one of the black holes passes near a star, that star is flung outward with astonishing force, not pushed gently, but hurled across space like a stone from a slingshot. This process of throwing stars outward acts like a braking system. It pulls the two black holes closer and closer until they form a pair locked together by gravity, orbiting one another like two enormous stones tied together by an invisible rope. A binary supermassive black hole is one of the strongest gravitational engines the universe can build. With every orbit they make around each other, they disrupt everything around them. They grab stars, swing them around with terrifying speed, and then launch them outward. These stars are not nudged or shifted slightly. They are kicked so powerfully that some of them are flung completely out of the galaxy forever. Over millions of years, again, millions written in words, this repeated slingshot action carves out a deeper and deeper empty region around the black holes. It hollows out the galactic core, creating a giant cavity where once there were tightly packed clusters of stars. The center becomes like a bowl with its contents scooped out. Now imagine this happening not once but many times. Not twice, but 10 times. Perhaps even a dozen times. Over billions of years. Billion spelled out. Every time a galaxy fell into the center of Abel 85, every time a new black hole sank inward to merge with the last, every time another round of slingshot violence kicked stars outward into the vast darkness, the hollow in the center grew larger, deeper, and stranger. Holm 15A is the product of this long, repeating cycle. It is not a normal galaxy built by calm processes. It is a giant sculpture shaped by repeated violence, repeated mergers, repeated gravitational storms. 10 or more major galaxy mergers have taken place throughout its history. Each one added mass, each one added energy, each one ripped away stars from the center, each one deepened the hollow. This is why the central region of Holm 15A is so unbelievably huge. Most galaxies have small, bright, cramped centers filled with dense packs of stars. Holm 15. A, in contrast, has a central hollow so large that it could swallow our entire Milky Way galaxy without blinking. If you took the Milky Way and dropped it into the empty space in the middle of Holm 15A, it would float there, lost in that enormous darkness, with room to spare. But this hollow at the centre is not truly empty. It is filled with the unspoken record of everything the galaxy has endured. Every surviving star carries the memory of ancient collisions within its motion. Their paths through space are twisted, bent and stirred by countless encounters with overwhelming gravity. No human machine could create forces like these. No technology we know or dream of could shape motion in this way. Computer simulations show that the stars near the core move like tangled strings blowing in a chaotic wind. They twist and loop. They weave around invisible gravitational knots. They speed up, slow down, drift, and then suddenly swing in strange directions. No two stars follow the same orbit, because no two stars were shaped by the exact same sequence of events. They have been tugged by tides, flung outward by black holes, and then pulled back again into new wandering patterns. This chaos is not true disorder. It is a kind of cosmic memory. Gravity remembers everything, every merger between galaxies, every star that was thrown outward, every burst of energy that shook the galaxy from within. All those moments are carved into the orbits of the stars that remain. The stars we see today in Holm 15A are survivors of an ancient era. They are old, they are red, they are faint. They were born long before our Milky Way formed, long before our sun lit up its first rays, long before planets like Earth cooled and hardened. They have been shining for billions of years, and the bright blue light of youth faded from them a long time ago. What remains is a soft glow, like embers that continue burning even after the fire is gone. These stars now drift silently across an enormous volume of space. The core that once might have held thick swarms of bright young stars is now a calm, low-density region, ruled by the supermassive black hole at its heart, a black hole so massive that its gravity shapes everything around it. Yet the hollow core is not the only evidence of Holm 15A's violent and dramatic past. Far beyond the centre, stretching into the outer halo of the galaxy, there is a faint and ghostly glow. This glow is made of long, thin streams of stars and wide arcs of scattered light. These are the leftovers of smaller galaxies that were torn apart when they fell toward the centre of the cluster. These streams are like fingerprints left behind by forces that no longer exist. They are smudges across starlight, fragile and barely visible unless you look with great care. They whisper a truth. Many galaxies that entered Abel 85 did not survive in one piece. They were pulled apart, shredded and scattered. Their stars became part of the giant cloud that surrounds Holm 15A today. And so the story of Holm 15A is not just the story of one galaxy. It is the story of many galaxies, perhaps dozens, that passed through the heart of a crowded universe, collided over and over again, and slowly merged into a single enormous giant. It is the story of billions of years of motion, energy, and change. It is the story of gravity as an artist, carving and reshaping the same region of space again and again until only the largest and oldest survivor remained. Holm 15. A's hollow centre is not simply an empty region. It is a monument built from everything the universe once was, chaotic, crowded, restless, and endlessly creative. It is a silent museum filled with ancient survivors whose paths through space tell the long, complicated story of a cosmos that never stopped moving, never stopped merging, and never stopped becoming something new. In that ancient cluster, the once graceful spirals did not keep their beautiful arms. Those long, winding structures were torn apart piece by piece, like ribbons caught in a storm. Smaller elliptical galaxies, which once floated calmly through space, were pulled and stretched until they looked like thin streaks of starlight. Some galaxies lost everything they once held. Their gas was taken, their structure erased, and only their stars remained, drifting aimlessly through the cluster like lonely travellers with no home left behind. Holm 15 gathered many of these wandering leftovers, wrapping them into its enormous outer layers as if it were slowly building a cloak made from the remains of other worlds. The environment of the cluster made this process even faster. Abel 85, the cluster that surrounds Holm 15A, is not a calm or peaceful place. It is more like a gigantic furnace made of gravity, roaring and active, where nothing stays still for long. Galaxies inside it fall toward the centre with great speed, faster than they can settle down or find any kind of balance. They crash into one another again and again, far more often than galaxies living out in the quieter parts of the universe. Each one of these encounters pours more energy into the cluster. It heats the gas until its temperature reaches many tens of millions of degrees. At such extreme heat, the gas glows in powerful X-ray light, creating a shining cloud that wraps the cluster in a shell made of invisible fire. Within this blazing environment, galaxies lose the cold gas that they need to make new stars. That gas is swept away or boiled off by the heat, leaving galaxies dry, reddish, and silent, with no way to create new generations of starlight. Holm 15 sits directly at the heart of this enormous furnace. It is positioned deeper than any of its neighbours, right inside the deepest part of the cluster's gravitational well, where the pull is strongest. Because of its position, it has swallowed more material than any other galaxy nearby. It has merged with countless companions. It has gone through more violent encounters than almost any galaxy we know. And now, after all those collisions and all that swallowing of smaller galaxies, Holm 15A has reached a point where it no longer forms stars. That simple fact tells us something meaningful. Its wild, violent youth has come to an end. There is no cold gas left inside it to collapse and create new suns. There is nothing waiting to ignite bright new light. All the material that could have been used for star formation has already been burned, scattered, heated, or absorbed. What remains inside Holm 15A is a slow and steady balance, a kind of long, gentle settling that takes billions upon billions of years. The galaxy has reached something like cosmic adulthood, or perhaps an even later stage, something like old age on a truly unimaginable scale. It exists in a quiet phase now, defined not by dramatic creation, but by memory and stability, like an elder who has lived through enormous storms and now rests in calm silence. Yet even in that quiet age, the black hole at the galaxy's centre still grows. It no longer grows quickly, and it no longer devours great rivers of matter the way it once did. But every star that drifts too close and falls into its grasp increases its mass by a tiny amount. Every thin wisp of gas that manages to escape the cluster's heat and drift inward adds just a little more weight to the monster at the centre. If the universe lasts for trillions of years, many times longer than its current age, this black hole may continue to gather more and more matter. But for now, its period of fast growth is over. It spent its early years feeding with fury, its middle years merging with the black holes of other galaxies, and now it rests as a huge dark giant that grows only little by little. When we stare at Holm 15A, we are not simply seeing another galaxy. We are looking at something like the final chapter of a whole pathway of cosmic evolution. Smaller galaxies became larger ones. Many active black holes became quiet and dormant. Structures full of gas became structures stripped clean. What we see in Holm 15A is the endgame of how gravity builds the biggest objects in the universe. It is a place where galactic collisions have slowed almost to nothing. A place where the largest black holes lie in deep, cold sleep. A place where the light has faded until it is thin and old, where nothing burns brightly anymore. And yet, even in this quiet, a deeper mystery still remains. The real question does not lie only in the mergers that built the galaxy's huge envelope. It lies in the enormous black hole at its core, a black hole so heavy that it challenges everything we think we understand about how such objects form. What exactly happened when the smaller black holes at the centres of merging galaxies spiraled toward each other? How did their twisting dance carve out a hollow thousands of light years wide in the centre of Holm 15A, leaving behind a space where stars should exist but do not? What kind of violent, invisible process could have built one of the heaviest black holes in the entire observable universe? To find those answers, we need to move inward, far closer to the core than ordinary starlight can take us. We must enter the region where gravity becomes strong enough to erase the paths of stars, a place where nothing moves freely but instead is guided by the unseen pull of a single titanic object. There, inside the black hole's sphere of influence, lies the truth behind the extreme heart of Holm 15A. Galaxies come in many shapes, but inside the crowded and turbulent galaxy cluster known as Abel 85, even the most beautiful and delicate spirals do not keep their shape for long. Their graceful arms, which once curled like the arms of a dancer, are torn apart by the constant pull of gravity in every direction. Those arms are stretched, twisted, and finally shredded into pieces. Smaller elliptical galaxies, which usually look smooth and oval, are pulled so violently that they become long, thin ribbons of stars. Some of them are stripped down even further, losing their outer layers of gas and dust, until nothing remains except loose stars drifting freely through the cluster. These lonely stars no longer belong to any galaxy at all. They become intergalactic wanderers, moving silently between the giants that ruled their space. Among the many galaxies inside this cluster, Holm 15A stands as the one that has consumed more remnants, more debris, and more pieces of destroyed galaxies than almost any other. As these broken leftovers drift through the cluster, Holm 15A gathers them into its enormous envelope, adding their stars to the already gigantic cloud of light that surrounds it. This process does not happen slowly or gently. It is pushed forward by the harsh environment of the cluster, where gravity never sleeps, and everything is pulled toward the center with relentless strength. Abel 85 is not a peaceful place. It is not a soft neighborhood where galaxies can live quietly. It is a gravitational furnace, a place where forces are so strong that galaxies fall toward the middle faster than they can settle into stable orbits. Instead of circling calmly, they crash into one another again and again. They merge far more often than galaxies that live in quieter regions of the universe. Every collision, every violent encounter, adds enormous energy to the cluster. That energy heats the gas that fills the space between galaxies until it reaches temperatures of tens of millions of degrees. Gas that hot no longer glows in warm, visible colors. Instead, it shines in X-rays, creating an invisible shell of fire that wraps around the cluster like a ghostly storm. Inside this storm, nothing cold can survive for long. The superheated gas strips other galaxies of their cold gas the way a desert wind strips leaves from a tree. Without that cold gas, these galaxies cannot create new stars. They become quiet, red, and aged, with no fresh light being born inside them. Holm 15 sits at the deepest part of this furnace, the very heart of the cluster. It has consumed more material than any of its neighbors. It has merged with more galaxies. It has sunk into the cluster's gravitational well farther than anything else around it. Because of this long history, the galaxy has reached a point where it no longer forms stars at all. Its violent period is finished. There is no cold gas left to collapse under its own weight and ignite into new generations of stars. The galaxy has entered a long period of calm, a kind of cosmic adulthood, or perhaps even something close to old age. It is a stage defined not by growth or creation, but by stability and memory. And yet, even in this quiet phase, the supermassive black hole at the center of Holm 15A continues to grow, though at a very slow pace. Every now and then a star wanders too close and is tossed into the black hole's reach. That star adds a tiny fraction of mass to it. Every little piece of gas that escapes the terrible heat of the cluster and drifts inward also feeds it, little by little. Over trillions of years, time spans far longer than the current age of the universe, this black hole may continue to gather more matter. But the period of fast, furious growth is over. It spent its youth devouring material rapidly. It spent its middle age merging with other black holes that came from galaxies it collided with. Now it rests, enormous, silent, and patient. When we look at Holm 15A today, we are not only seeing a galaxy, we are looking at the final chapters of a long story, an entire line of cosmic evolution that began when the universe was still young. We are seeing how small galaxies became bigger ones, how bright, active black holes became quiet, heavy giants, how galaxies full of gas and potential slowly changed into old structures stripped clean by time and violence. Holm 15 shows us what gravity eventually creates when it has billions upon billions of years to work without rest. It shows us the endgame of assembly, the final act in a play shaped entirely by gravitational pull. In this place, collisions have finally slowed down. The largest black holes have grown so big and so stable that they sleep, waking only when a new piece of matter slips into their reach. The light that fills this region is old, stretched, cooled, and dim. But even though Holm 15A looks like a monument to endings, its story is not finished. There is a deeper mystery hidden inside it, a mystery that comes from all the collisions and mergers that built its central black hole. What truly happened when the giant black holes at the hearts of merging galaxies met each other? How did their orbits twist and dance around one another until they carved out an enormous hollow thousands of light years wide? How could such a meeting create one of the heaviest black holes in the entire observable universe? These questions lead us to the dark center of the galaxy, the place where stars vanish without leaving any trace, and where gravity shapes everything while showing none of its own face. There, inside the black hole's sphere of influence, lies the secret of Holm 15A's extreme heart. It is a region so powerful that even light cannot escape the pull of the central monster. Stars are flung away like sparks as the black hole settles into its final form. Every time two supermassive black holes merge, the new one becomes larger, heavier, and more difficult for the universe to understand. That process has happened many times inside Holm 15A, each time building something stranger and more powerful than before. Understanding this inner region means stepping into a place where normal rules break down. Space itself bends, time stretches, orbits twist into shapes we cannot see directly. But by studying how galaxies merge, how their black holes crash together, and how that dance sculpts the center of the galaxy, we begin to uncover the truth behind the vast hollow that defines Holm 15A. It is not just empty space. It is the scar left behind by giants. It is the footprint of gravity working on a scale almost beyond imagination. And as we move forward into the next part of the story, the focus turns to that hidden engine, the heart that shaped everything we see. It is there, in the darkness where stars disappear, that the real answers wait for us. Answers about how black holes grow, how they shape galaxies, and how they build structures heavier and stranger than anything else in the universe. The universe, vast and silent to the human ear, is a place of motion, attraction, and tremendous forces that operate on scales so immense that they are almost impossible to imagine. Among these forces, gravity stands as the quiet sculptor of cosmic structures. It shapes galaxies, guides the paths of stars, and controls the fates of entire clusters of galaxies. One of the most intriguing and dramatic manifestations of gravity occurs when massive objects interact in a way that results in what astronomers call a gravitational slingshot effect. These effects, though invisible to the naked eye, leave enduring marks in the cosmos, including the creation of enormous, almost hollow cores in some of the largest galaxies in the universe. To understand a gravitational slingshot effect, it is helpful to first imagine a simpler, smaller scale version. Picture a small planet, like a spacecraft, approaching a massive planet such as Jupiter. As the spacecraft comes near, the immense gravity of the planet pulls it closer, accelerating it along its path. If the spacecraft passes at just the right angle and speed, it can be catapulted forward, leaving the planet behind but carrying away some of the planet's gravitational energy. In our solar system, humans have used this trick for decades to send spacecraft on long journeys across the stars, using the gravity of planets to slingshot them toward their distant destinations without using enormous amounts of fuel. In this context, the slingshot is a method of gaining speed and changing direction, a maneuver that harnesses the invisible pull of gravity. In the environment of massive galaxies and galaxy clusters, gravitational slingshots happen on a scale so vast it almost defies comprehension. Here, the players are not small spacecraft, but entire stars, stellar remnants like black holes, and sometimes even entire small galaxies. In the heart of galaxies like Holm 15A, which resides at the center of a massive galaxy cluster, gravity is so powerful that it orchestrates a complex cosmic dance. Stars are not simply moving in smooth circular orbits. They are constantly interacting, sometimes in violent or chaotic ways, as they respond to the gravitational pull of both the supermassive black hole at the galaxy's center and the gravitational influence of other stars and smaller black holes. When two supermassive black holes, or a black hole and a dense cluster of stars, come close enough, their mutual gravity can create conditions that send stars hurtling away from the galactic center at incredible speeds. These stars are not destroyed. Rather, they're flung outward in trajectories that remove them from the innermost regions. Each star that is ejected carries away a tiny amount of energy and momentum. Over millions and billions of years, this process can repeat countless times. With each interaction, more stars are pushed away from the center, gradually excavating an enormous hollow within the galaxy. This hollow is what astronomers refer to as the galaxy's core, though it is very different from what one might expect when hearing the word. Instead of a dense concentration of stars, this core becomes a vast, relatively empty region, smooth and quiet compared to the bustling starfield surrounding it. The gravitational slingshot effect works most efficiently when massive bodies, like black holes, come close to one another. During a galactic merger, a common event in the universe, the central black holes of the colliding galaxies can meet and form a binary system, orbiting each other while drawing in surrounding stars. Stars that venture too close to this binary can be caught in the gravitational tug-of-war, accelerated to enormous speeds, and sent shooting out into the galaxy or even beyond its borders. Each ejected star is a small messenger of the colossal gravitational forces at work, carrying away energy and leaving behind a quieter, emptier center. This process does not happen quickly. It is measured in millions or even billions of years. Galaxies are patient sculptors, shaped by time and gravity in ways that humans can only slowly trace through observation and simulation. Astronomers study the distribution of stars, the motion of stellar remnants, and the shape of galactic cores to infer the history of these gravitational slingshot events. In galaxies with exceptionally large cores, like Holm 15A, the evidence points to repeated interactions over a long history of galactic collisions and black hole encounters. The size of the core tells a story. The larger the hollow, the more stars have been ejected, and the more dramatic the cosmic slingshot events that have occurred over eons. Interestingly, this process also explains some of the most striking features of the largest galaxies. In addition to carving out enormous cores, gravitational slingshots help shape the smooth, almost featureless appearance of these regions. Stars are ejected preferentially from the central areas, leaving the outer parts of the galaxy relatively undisturbed. The result is a core that appears less like a chaotic jumble of matter and more like a deliberate, quiet space, the shadow of gravitational forces at their most extreme. The slingshot effect, therefore, is not destructive in a chaotic sense, but is an ordered sculpting of stellar architecture, a cosmic carving performed with invisible hands over billions of years. Another fascinating consequence of this process is the connection to the growth of supermassive black holes themselves. As stars are ejected from the centre, some of their mass, or the gas released from them, may be drawn toward the black holes fueling their growth. In this sense, gravitational slingshots are not only a mechanism for hollowing out the core, but also part of the intricate feedback loop that shapes the evolution of galaxies and their central black holes. Every star thrown outward is a piece of a cosmic puzzle, linking the fate of individual stars to the growth and structure of the galaxy as a whole. To imagine this visually, one might picture a vast whirlpool at the centre of the galaxy, with stars being pulled toward the black hole and then flung outward in curved paths, some escaping entirely, others settling into wider orbits. Over billions of years, these repeated gravitational interactions create a core so vast that it challenges our intuition, a place where the density of stars drops to an astonishingly low level compared to the surrounding regions. What appears to be emptiness is, in fact, the record of countless energetic interactions, a silent testament to the invisible forces that govern the universe. The gravitational slingshot effect also highlights the universe's elegance and efficiency. Gravity, a force that feels gentle on Earth, becomes a mighty sculptor on galactic scales. It moves stars without touching them, reshapes entire galaxies without violence, and creates structures that are both enormous and delicately balanced. The enormous core of a galaxy like Holm 15A is a direct result of this cosmic choreography, where the gravitational dance between black holes and stars has gradually cleared out the centre, leaving behind a smooth and imposing hollow. At the heart of the enormous galaxy known as Holm 15 lies a place where starlight seems to fade away, and the familiar rules of matter begin to dissolve into something stranger. It is a region not shaped by gas or dust or even by stars, but by the bending of space itself. What looks like an empty hollow in the middle of this giant galaxy is actually the long-lasting signature of something far deeper than ordinary galactic collisions. It is the footprint left behind by supermassive black holes merging again and again across almost the entire history of the universe, reshaping space the way rivers reshape landscapes, slowly but relentlessly. To understand why Holm 15A looks the way it does today, we have to understand the engine that built it. Not an engine made of burning fuel or spinning metal, but a gravitational engine, a kind of cosmic machinery forged in darkness. It is a place where light becomes silent, but motion continues to tell a very clear story. When two galaxies collide, their stars almost always pass by each other without touching, because the distance between stars is enormous. But their black holes, sitting at the centers like anchors, experience something completely different. They are drawn toward each other in a way that seems almost inevitable, as if gravity were following a script written into the bones of space and time itself. The long dance toward collision begins with a strange but well-understood process astronomers call dynamical friction. As each black hole moves through its galaxy, it does not glide through empty space. It pulls on the stars around it, creating a faint but important wake behind it, a kind of gravitational drag. This slight overdensity of stars tugs backward on the black hole, stealing a bit of its motion, draining its orbital energy very slowly. Over tens of millions or even hundreds of millions of years, this repeated draining pulls the black holes inward, closer and closer, until they are no longer travelling alone. They become a bound pair, orbiting each other in a slow spiral that tightens with every passing age. Once this happens, everything around them changes. Stars that wander too close to this pair feel a powerful tug from two directions at once. They are whipped into extreme speeds and flung outward, hurled into the far reaches of the galaxy. And this is not chaotic or random scattering. It follows the same mathematical pattern every time it happens, as if the universe were repeating a well-practiced dance. The black hole pair carves out a three-dimensional cavity around itself, not through explosions or heat, but through the steady choreography of gravity alone. Every star that gets flung outward deepens that hollow. Every orbit that is disturbed makes the center a little emptier. And this is not a one-time event in Holm 15A. It happened not once, not twice, but repeatedly across billions of years. Each major galactic merger brought with it another enormous black hole. Each new giant slowly sank toward the center, merged with the previous one, and strengthened the hollow core even further. The result is a central region unlike almost anything else we have ever seen. It is one of the largest low-density galactic cores ever discovered. It stretches across tens of thousands of light years, so wide and so empty that its very existence seems to go against what we expect from galaxies, which normally pack their stars more tightly toward the center. But instead of contradicting the universe's rules, this hollow confirms them. It shows how important black hole pairs and black hole mergers are in shaping the larger structures we see today. As these black holes merge and grow heavier, their influence expands outward. Stars tens of thousands of light years away feel the pull. Their orbits begin to stretch and twist. Their paths lose the elegant order they once had and become more chaotic. The gravitational field around the center grows deeper but also smoother, like a well worn down by unimaginable spans of time. The central region becomes dim not because nothing is there, but because everything that could shine, every star, every glowing cluster, has been pushed outward by the invisible weight of the black hole at the center. The most remarkable moment in this entire process arrives when two supermassive black holes finally merge into one. When their event horizons touch and combine, it ranks among the most violent transformations in the universe. And yet, almost none of that violence appears as visible light. Instead, the energy bursts outward as gravitational waves, ripples that stretch and squeeze space as they travel, racing outward at the speed of light. In smaller galaxies, the black holes are lighter, maybe only millions of times the mass of our Sun, and the gravitational waves they release are faint. But in Holm 15A, the merging black holes can weigh billions or even tens of billions of solar masses. The waves they produce are gigantic beyond imagination, yet they spread across distances so enormous that by the time they reach the rest of the universe, they become too faint for our eyes or telescopes to see. They simply ripple through the galaxy cluster and fade into the background of the cosmos, leaving behind only the new, heavier black hole at the center. After the merger, the giant black hole settles into the lowest point of the galaxy's gravitational well. Any leftover stars near the center try to settle into new orbits, but there are not many of them left. The core has been scoured almost clean. Its density is unbelievably low. Most of the stars that once crowded that region were flung outward with huge bursts of energy, given motion by the black hole pair that no longer exists. The paths of those stars, wide, loose, looping, or strangely chaotic, show us the memory of the black hole's final dance, still written into their movement. The new central black hole, though much heavier than before, becomes strangely quiet. It has already consumed or driven away almost all the matter that might once have fed it. What makes Holm 15A extraordinary is not only the mass of its central black hole, but also the silence that surrounds it. A black hole weighing more than 20 billion times the mass of the Sun should, under normal circumstances, be one of the brightest objects in the universe. Gas falling into such a monster should create a glowing accretion disk shining like a quasar blazing across the darkness. But Holm 15A does not shine like that. It remains dim and quiet because the environment around its core has changed too much. Over billions of years, the same mergers that built the galaxy also stripped away or heated the cold gas that the black hole would need for fuel. The cluster that surrounds Holm 15A, Abel 85, contains gas that is incredibly hot and extremely thin. Instead of cooling down and falling toward the black hole, the gas stays buoyant, lifted by its own heat. It cannot sink, cannot collect, cannot feed the central engine. The result is a strange and almost paradoxical situation. A black hole of unbelievable mass that gives off almost no light at all. Its silence becomes one of the most important clues we have to understanding the entire galaxy. This quiet giant sits there, not roaring, not blazing, but resting in a state of cosmic balance. All the fuel that once could have fed it has been pushed aside, heated, stolen, or stretched thin across the galaxy cluster. What remains is a massive heart of darkness surrounded by a hollow so large it seems impossible. And yet it is exactly what billions of years of gravitational sculpting would naturally produce. Holm 15. A, with its vast empty core and its silent black hole, is not a mistake of nature. It is a masterpiece shaped by time. Sometimes, its greatest strength shows itself through emptiness, through stillness, through the quiet sculpting of gravity acting over ages beyond anything the human mind can easily imagine. And in that silence, deep in the hollow heart where starlight fades into the geometry of space, we find the story of black holes shaping a galaxy, one merger at a time, across almost the entire lifetime of the universe. In many galaxies and galaxy clusters across the universe, the brightest central regions shine like cosmic beacons, announcing the presence of active black holes. These glowing areas are usually full of powerful jets, spinning disks of gas, and sudden flares that burst like sparks as matter spirals inward and heats up to unbelievable temperatures. When a black hole is feeding, it is as dramatic and loud as a cosmic storm. But Holm 15A, one of the most unusual galaxies ever studied, does not follow this familiar pattern. Instead of a bright, blazing core full of drama, it shows only a faint, soft glow produced by ancient stars that have survived the galaxy's long history. There is no accretion disk, no jets, no fireworks, and no visible signs that anything hungry or active is living in the centre. The only thing that remains is the gravitational memory of everything that once fell inward. Even when astronomers look at Holm 15A with sensitive X-ray telescopes, hoping to find at least a small trace of high-energy radiation, they find almost nothing. The X-ray emission is extremely weak, barely a whisper compared to other galaxies. The sharp signatures that usually reveal fresh material falling into a black hole simply are not there. It is as if the central object has entered a deep and endless sleep. The black hole at the centre of Holm 15 has moved into a phase of long-term quietness, a kind of cosmic hibernation in which its gravity still rules over everything nearby, but its light has completely vanished. It has become a starless sun, a massive but silent anchor holding the galaxy together, a king who no longer speaks but whose influence still shapes the land. This silence, strangely enough, does not make the central engine seem small or weak. Instead, the silence makes it feel even larger, more mysterious, more overwhelming. When the usual noise and light disappear, gravity becomes the only message left behind, the only language the universe uses to communicate the presence of something unimaginable. Every star in the inner region moves according to this invisible master. The sudden rise in stellar speeds as they approach the hollow core, the wide stretching of the spectral lines that measure their motion, and the unusual way the galaxy's brightness changes from the centre outward, all point toward the same answer. Something enormous, compact, and completely invisible dominates the centre. Something that ordinary stars, no matter how many, cannot explain. The only kind of object capable of creating these powerful signs is an ultramassive black hole. the largest category of black holes known to science. Astronomers often talk about black holes that weigh a few billion times the mass of our Sun, and those alone are already considered giants. But the black hole in Holm 15A may be far more massive than that, possibly more than 20 billion times the mass of the Sun. To astronomers, the difference between a black hole of a few billion solar masses and one that reaches or surpasses 20 billion is not just a matter of counting. It changes everything. It changes the structure of the galaxy, the arrangement of its stars, the shape of its center, and the way space itself behaves. Smaller black holes, even those weighing several billion suns, influence only the inner tens or hundreds of light years of their galaxies. Their gravitational rule has a limited territory, but the black hole in Holm 15A may stretch its influence across thousands of light years, reaching distances so vast that its gravitational kingdom is as large as an entire dwarf galaxy. The space around it is warped so deeply that even stars far from the center feel the bend, as if they are walking on a landscape shaped by an invisible mountain. Because of this immense size and deep gravitational reach, the black hole in Holm 15A belongs to one of the rarest categories in the universe. Only a few known objects match it. The central black holes of the brightest galaxies in the Coma cluster share some similarities. The quiet but heavy black hole at the core of NGC 600 is another member of this strange group, and in the distant universe the brilliant quasar known as TON 618 shines because of a black hole that may also reach similar magnitudes. But unlike TON 618, which glows with a dazzling disk so bright that it can outshine entire galaxies, the black hole in Holm 15 A hides its extremeness behind total silence and darkness. It behaves more like a fossil left from a different cosmic age. It is not young, it is not active, it is not hungry. It is the final evolutionary stage of a black hole that has devoured everything within its reach. It has merged with every smaller black hole and swallowed all the gas and dust that ever drifted near it. Now, with nothing left to consume, it rests in a perfect stillness, sustained only by gravity. It is the calm after every storm that ever touched the galaxy. When we look at Holm 15A, we're not seeing a new or rising power, but a monument to everything that has already taken place. This leads to an even deeper truth about galaxies and the forces that shape them. Silence is not always a sign of emptiness. Silence can be a sign of completion. The black hole at the heart of Holm 15 is not quiet because it is weak. It is quiet because it has finished its great work. What were once wild, chaotic flows of gas have long since vanished. What were once bright, furious collisions between stars and clouds are now memories carved into the structure of the galaxy. The galaxy around the black hole is like a shell that holds the leftover pieces of that long story: ancient star remnants, disrupted orbits, stretched out streams of stars and currents of motion that no longer follow simple patterns. Every faint, lonely star in the hollow central region serves as a witness to the black hole's past. Each of them is part of the record, like tiny glowing letters in a diary written by gravity. Every curve in the brightness profile of the inner galaxy is a trace of something that once happened. An object that fell inward, a cluster that merged, or a cloud that was torn apart. What looks like emptiness is actually evidence. It is a story told through space instead of words. And this evidence continues far beyond the hollow interior. Even the outer regions of Holm 15A carry marks left by the central black hole, like fingerprints on a much larger canvas. The distribution of stars is smoother than in many other galaxies. The halo has fewer wrinkles and fewer obvious leftovers from smaller galaxies that once passed nearby. The absence of strong substructures in the outer envelope hints at the power of the central gravity. A black hole this large does not simply sit in the middle. It shapes the entire galaxy through long ages of bending, pulling, stretching, and balancing. Nothing in this galaxy is accidental. In a system as enormous as Holm 15A, gravity is not just a passive force that keeps objects from flying apart. Gravity becomes an ongoing negotiation between what remains and what has been expelled, between the past and the present, between what fell inward and what was thrown outward. After countless cosmic events, the galaxy has reached a delicate compromise. Its center is hollowed out. Its stars are older than the glowing populations found in more active galaxies. Its reservoirs of cold gas have been used up or heated until they became useless for star formation. and its black hole sits quietly in the center, no longer shining but still holding everything together. This is the engine of darkness. It is the invisible heart that defines Holm 15, and not by what it radiates, but by how it carves the structure of the galaxy. They do not announce themselves with light or noise. Sometimes they leave no direct trace at all, only motion reveals them. When astronomers study the faint stars that still orbit near the center, they find that none of them move randomly. Their paths are shaped, stretched, and twisted by a mass so great that it can bend the orbits of billions of stars without shining a single photon. The silence of Holm 15. A is not the silence of emptiness. It is the silence of a giant that no longer needs to roar, because gravity alone speaks for it. The universe has a peculiar way of hiding its most extreme and massive creations. Among all the cosmic objects, none are more elusive than black holes. They have no surface to touch, no colour to see, no reflection to catch the eye. Unlike stars which shine and scatter light in all directions, black holes offer no outline to follow, no silhouette against the dark canvas of space. You cannot weigh them like a planet or a star. You cannot measure their size with a ruler, nor detect their glow with a telescope. They exist in complete secrecy, hidden behind a flawless mask. Their essence is pure geometry, a shape defined by the invisible tug of gravity, wrapped in absolute silence. And yet, in the midst of all this invisibility, humans have found a way to measure them, to weigh the unseeable, to reveal the massive objects that emit no light at all. The story of Holm 15A is not just a tale of ancient cosmic violence or dramatic galactic collisions. It is also the story of human ingenuity, a testament to our ability to uncover secrets almost 700 million light-years away. At this staggering distance, in the cluster known as Abel 85, a galaxy harbours one of the largest black holes ever discovered, and we know about it not because we can see it, but because of the way it influences everything around it. In this sense, Holm 15A is both a monument of the cosmos and a mirror of human curiosity. Weighing a black hole is not about observing light, it is about tracing motion. Gravity, though invisible, leaves marks on everything it touches. Even when it produces no radiation, its influence is evident. Every star orbiting near the centre of Holm 15 carries a trace of the black hole's presence. Each path, each shift in speed, every slight distortion in the galaxy's faint inner glow tells a story. By carefully observing these motions, astronomers can reconstruct the mass that lurks hidden in darkness. They can read the gravitational fingerprints left by the invisible architect at the galaxy's core. Even before astronomers knew that Holm 15A housed a black hole of extraordinary size, there were hints that its centre was peculiar. Most galaxies gradually grow brighter toward their cores, a natural result of stars clustering in the centre. Holm 15A, however, defied this expectation. Its brightness did not rise toward the middle. Instead, it dimmed. The decline was neither gentle nor subtle, it was sudden and pronounced. The galaxy's inner light fell away smoothly, revealing a hollow that suggested something was missing. It was as though some invisible sculptor had carved out a vast cavity, leaving an emptiness too wide and too faint to have formed by chance alone. This hollow could not be ignored. It demanded an explanation that went beyond ordinary galactic processes. While galaxies can develop unusual structures, bars, lenses, double cores, misaligned orbits, or disrupted halos, the emptiness at the centre of Holm 15A was something different. It was too large, too smooth, and far too symmetrical to be a mere quirk of formation. The only process known to carve such a vast and regular void is the repeated passage of binary supermassive black holes. When two such titanic objects spiral around each other, their combined gravitational pull can eject stars from the galaxy's core, slowly hollowing it out. Over billions of years, if many black holes merged within a galaxy, the resulting central object would be unimaginably massive. But suspicion, no matter how compelling, is not the same as proof. To measure a black hole, astronomers must look not at the void itself, but at the stars moving around it. Every star within the inner few thousand light-years of Holm 15 carries a whisper of the gravitational pull at the centre. Their speeds, directions, and the spread of their velocities, known as velocity dispersion, become a map of the invisible mass they orbit. The faster and more varied their motion, the deeper the gravitational well they traverse, and the deeper the gravitational well, the heavier the central object must be. This technique is far from simple. It requires splitting the galaxy's light into its component colours, analysing minute shifts in wavelength caused by the motion of stars. When a star moves toward Earth, its light compresses slightly. When it moves away, the light stretches. By collecting these signals from millions of stars and modelling them together, astronomers can reconstruct the shape of the gravitational field at the galaxy's heart. From this, they can deduce the mass that must exist to produce such effects. In the case of Holm 15A, this task demanded instruments of exceptional precision. The first hints came from the Very Large Telescope in Chile, using an instrument called MUSE, a spectrograph capable of measuring the velocities of stars across a wide field of view. When astronomers directed it toward Holm 15A, they observed something astonishing. Stars near the centre were moving at extreme speeds. These motions could not be explained by the visible matter in the galaxy. There simply was not enough starlight or gas to account for such rapid orbits. Something massive, something invisible, was anchoring the system. Early dynamical models suggested a black hole weighing nearly 40 billion times the mass of the Sun. This estimate stunned even scientists who had expected extraordinary results. If accurate, this would make Holm 15A's central black hole one of the heaviest ever detected in the observable universe. But early measurements are always provisional. The galaxy's core is diffuse and extended, and even small uncertainties in brightness, density, or orbital modelling could dramatically shift the result. Confirmation was needed. Years later, follow-up observations brought refinement and increased confidence. Using advanced methods and new instruments, astronomers could isolate finer details of the galaxy's starlight. At the Keck Observatory in Hawaii, adaptive optics allowed them to correct for atmospheric distortion, revealing subtler structures in the motion of stars. Applying these data to more sophisticated models, they revised the black hole's mass downward to approximately 22 billion solar masses. Still enormous, still among the largest black holes ever measured directly, but more consistent with the structure and history of the galaxy. Whether the mass is 22 billion or 40 billion suns, the central black hole of Holm 15A is beyond human intuition. It is a gravitational anchor unlike nearly anything else in the cosmic neighbourhood. Unlike luminous quasars, which blaze brilliantly as they feed on streams of gas, Holm 15A's black hole is silent. It is dormant, having long consumed or heated the galaxy's cold gas, leaving nothing to feed upon. Without an accretion disk, without jets, without X-ray emissions, it is invisible. Its presence is known only through the movement of stars, and yet that motion leaves no doubt. Stars closest to the centre move so swiftly that only a massive, compact object could be responsible. If the mass was spread over a larger area, it would be visible in the galaxy's light. But there is no such light. The mass is concentrated, dark, and unmistakably a black hole. This method of weighing the invisible is profoundly elegant. It inverts the very idea of observation. Instead of detecting light from the object itself, astronomers study the stars around it. The light that reaches us indirectly reveals the nature of what cannot be seen. Stars near the core move like debris caught in a whirlpool, tracing paths twisted and accelerated by the immense gravity of the black hole. Farther out, motion becomes more orderly, yet even there, stars retain the memory of the gravitational pull at the centre. The faint glow of the galaxy spreads smoothly with distance, but the signature of the massive centre persists, whispering the same truth across vast cosmic distances. Holm 15A became a benchmark for this technique, a demonstration of how far dynamical modelling can be pushed. It showed how the careful observation of starlight could illuminate the properties of an object that emits no light at all. The galaxy's hollow centre, once merely a curiosity in its brightness profile, became the key to understanding one of the most extreme black holes in the universe. Through motion, the invisible was weighed, and through patient observation, humans were able to uncover a cosmic secret nearly 700 million light-years away. The journey to this discovery is a story of patience, precision, and creativity. It is not about sudden flashes or dramatic collisions, though those two shaped the galaxy over billions of years. It is about the quiet, steady influence of gravity and the ability of humans to interpret its subtle signs. Holm 15A A's black hole is not a blazing beacon. It is a monument in the dark, a relic of ancient mergers, a record of repeated encounters with other supermassive black holes that sculpted the galaxy's hollow heart. And yet, it is not beyond comprehension. Through meticulous observation, sophisticated modelling, and an understanding of motion and light, astronomers were able to reveal its immense mass. Even now, the scale of the black hole challenges imagination. To grasp 22 billion or 40 billion solar masses is to confront a magnitude almost impossible to picture. It dwarfs every star in the galaxy, it dominates the motions of countless stars, and it anchors Holm 15A as a gravitational colossus. It reminds us that the universe contains extremes beyond our everyday experience, that some objects are defined not by what we see, but by the influence they exert across millions of light years. Holm 15. A is not only a story of an extraordinary black hole, it is a story of how we, from our small vantage point on Earth, can understand and measure phenomena billions of times more massive than our Sun, hidden deep in the darkness of space. It is a story of ingenuity, of interpreting motion as a language, of reading shadows cast not by light, but by gravity. In this sense, the galaxy and its central black hole are also a testament to human curiosity, to our ability to reveal the unseen and to uncover truths hidden in the silence of the cosmos. The elegance of the method, the beauty of the insight, and the scale of the discovery all combine to make Holm 15 an exceptional case study. Stars are the messengers, carrying the whispers of a gravitational field that bends, twists, and accelerates them. Instruments like Muse and the adaptive optics at Keck allow us to hear those whispers and translate them into measurements of mass. The vast hollow at the centre of the galaxy, once merely an intriguing feature, becomes the key to understanding a gravitational monster that has quietly existed for billions of years. The centre of this strange and enormous galaxy challenged everyone who tried to understand it. The heart of the galaxy was so empty of stars that it became difficult to measure anything with certainty. In most galaxies, the inner region is crowded with bright stars, giving astronomers many points of reference to study. But here, near the centre, the number of stars became very low, like trying to study a landscape where the landmarks have almost disappeared. This soft, smooth glow coming from the remaining old stars did not offer sharp edges or clear features. Every small detail had to be corrected with extreme care, because even a tiny error could lead to a completely different interpretation of what was hiding at the centre. Because of this difficulty, every assumption that astronomers usually depend on had to be examined again and again. They needed to check how stars might move in different directions, how the star populations might differ from those in other galaxies, how much dark matter might be present, and how the three-dimensional structure of the galaxy might change once it was projected onto a flat image from Earth. Nothing could be taken for granted. Each idea was tested, improved, and then tested again, until the researchers were certain that no major mistake remained. To understand the inner structure of this galaxy, scientists created models made from many millions of simulated star orbits. Each simulated orbit was slightly different from the next, like painting the same picture again and again but with tiny changes each time. Then they compared every one of these millions of orbits to the actual observations gathered from telescopes on Earth and in space. Eventually, after countless comparisons, the true shape of the gravity at the galaxy's centre slowly revealed itself. It was like watching a huge sculpture emerge from a block of marble, not in a sudden flash, but through steady and persistent effort. When they finally looked at the result, they found that only one explanation made sense. The galaxy now known as Holm 15A contained a black hole of unbelievable weight resting at its heart. It did not shine, it did not roar, and it did not announce itself with any dramatic display. Yet it shaped the motion of all the stars drifting through its enormous range of influence. Astronomers call this region the black hole's sphere of influence, meaning the area where its gravity becomes the most powerful force and overwhelms everything else. In most galaxies, this sphere is small. In our own Milky Way, the sphere around Sagittarius, a star, stretches only a few light years in all directions. That is enough to control the motion of stars near the centre of our galaxy, but it remains a tiny region compared to the size of the whole Milky Way. However, in Holm 15A, the sphere of influence may extend across thousands of light years. Imagine an invisible bubble of gravity so vast that entire clusters of stars orbit under its command. Every star close to the center must follow paths shaped directly by the black hole's unseen pull. Nothing within that huge volume is free from its gravitational rule. This is the important truth that scientists discovered. The black hole does not simply control the small region around it, as many black holes do. Instead, it controls the entire center of the galaxy. It acts not like a small gravitational anchor, but like a massive system that defines the very structure of the galaxy's core. What makes this even more extraordinary is how silent this gigantic system is. If the black hole were feeding, if it were actively swallowing gas and dust, the area around it would blaze with intense light. Jets would burst from its poles, and disks of superheated matter would whirl around it at nearly the speed of light. The region would shine so brightly that it could be seen from hundreds of millions of light years away. Instead, there is none of that. The stars move quietly through space. No swirling disk of glowing gas appears. No jets of radiation shoot outward. No brilliant flares signal matter falling into the darkness. The very lack of light becomes one of the most important clues. The silence, combined with the graceful motion of the stars, reveals the black hole's influence more clearly than any explosion of radiation could. It is massive, ancient, dormant, and yet completely central to the galaxy's structure. This is how astronomers weigh something they cannot see. They do not need the black hole to glow or scream or tear apart matter in a dramatic fashion. Instead, they watch the movement of the stars around it. Those stars reveal everything. Their speed tells the black hole's mass. Their curved paths outline the shape of its gravitational pull. Their orbits form a signature that cannot be forged or hidden. In a universe where light can be bent, blocked, or distorted, gravity is almost always honest. And in Holm 15A, gravity speaks loudly enough to tell the whole story. Learning the true weight of this black hole required not just powerful instruments, but also a willingness to accept scales that stretch beyond human imagination. A mass of more than 22 billion times the mass of our Sun is a quantity that no human mind can truly picture. It is heavier than many entire galaxies. If something with that mass were placed in the center of the Milky Way, it would dominate not just the inner region near Sagittarius, a star, but would influence a huge part of the galaxy, reshaping the paths of stars thousands of light years away. The edge of this black hole, the boundary from which not even light can escape, would be larger than our entire solar system. Picture a region of total darkness extending across a distance measured in hundreds of billions of kilometers. Inside that invisible boundary, the fabric of space and time bends so sharply that nothing can climb out, not even the fastest thing in the universe. Yet from Earth, many hundreds of millions of light years away, that monstrous region appears as a single point, silent and steady, a deep well in the night sky that cannot be seen directly. Weighing black holes like this is not simply a technical exercise. It becomes a philosophical act as well. It proves that even the quietest and most hidden objects in the universe leave a record of their presence. Their gravity shapes the worlds around them, and their influence can be traced across distances so great that no human journey could ever cross them. Even silence has meaning. Even darkness has weight. Even something that never shines can reveal its story through the motion of the stars that orbit it. This discovery also opens new questions about the universe. Understanding a black hole of such incredible size helps us learn how black holes grow, how they reach such unimaginable scales, and what they can tell us about the galaxies that live in the most crowded, most ancient regions of space. A sleeping black hole of more than 22 billion solar masses does not simply sit quietly. It carries the history of its galaxy within its gravity. It holds clues about ancient collisions, long-lost stars, and the past life of a cluster that has existed for nearly the whole age of the universe. A black hole is not simply a thing that waits silently in a corner of space. It is not defined only by the spot where it sits, or by the dark sphere that marks its event horizon. Instead, a black hole is defined by the vast territory where its pull rules everything around it. A black hole controls space, shapes motion, and bends the paths of stars and gas even at distances so enormous that our minds strain to imagine them. Its influence is a kind of invisible empire, stretching far beyond the boundary where even light gives up. And in the galaxy known as Holm 15A, this invisible empire is not just large, It is overwhelming. It is so wide, so deep, and so calm in its dominance that the entire galaxy around it takes the shape of a faint shell, a ghost-like echo of everything that once fell inward, everything that surrendered to the black hole's gravity across almost the entire age of the universe. To understand a black hole like this, astronomers do not simply calculate a number and write it down. Understanding the mass of such a sleeping titan is really about understanding how an extraordinary weight changes everything near it. It is about seeing how that weight rearranges the structure of a galaxy, how it controls the motion of stars, how it shapes the overall behavior of the system, and even how it influences the galaxy's destiny far into the future. So when astronomers discovered that the central black hole in Holm 15A weighs more than 20 billion solar masses, meaning it is heavier than 20 billion stars like our Sun combined, they realized they were not just measuring some exotic object. They were rewriting part of our expectations about how galaxies and black holes grow. Most galaxies, even the giant ones, follow a kind of predictable pattern. Their central black holes grow in proportion to the brightness of the galaxy, or the number of stars in the central bulge. That pattern has been one of the strongest relationships in all of galaxy formation theory. You look at the galaxy's core and you can usually predict the size of its black hole, but Holm 15 refuses to obey those rules neatly. Its black hole is far too massive for the faint amount of light in the core. It is too extreme for what the visible number of stars suggests. It stands outside the usual pattern, like a giant that grew faster than its home could keep up with. It is an outlier, a clue that its story is different, more violent and more complicated than the quiet evolution many galaxies experience. The environment explains part of this. Holm 15 lives inside a dense cluster called Abel 85, where galaxies do not drift calmly as they do in emptier regions of space. In such crowded cosmic cities, galaxies crash together more often. They fall toward the center more quickly. Their orbits shrink as the cluster pulls them inward. Over billions upon billions of years, these interactions become a kind of fuel for central black holes. Each time two galaxies merge, the stars mix, the gas mixes, and the smaller central black hole joins the main one. The incoming black hole sinks to the center, dragged in by gravitational friction, and then the two of them fuse into something bigger. Over time, over countless collisions and over an age of the universe measured not in millions but in billions of years, these mergers act like amplifiers. They grow the central black hole faster than the galaxy itself can grow. The stars of the galaxy spread outward, thinned by tidal forces that tear material away. Light becomes diluted, stretched out. Meanwhile, the black hole at the center accumulates mass without losing its concentration. It sits like a stone in the middle of a pond while everything else is stirred and shaken around it. The result is a system where the black hole becomes disproportionately heavy, a kind of gravitational monument wrapped inside a faint, ghostly, oversized envelope of starlight. Holm 15 represents the extreme end of this entire process. Its hollow core is the record of countless black hole mergers. Its smooth outer halo is the record of all the galaxies it absorbed, and its monstrous central black hole is the record of something deeper, the difference between how light behaves and how gravity behaves over cosmic time. Stars shine brightly and lose energy. Gas glows, cools and fades. Galaxies as a whole become dimmer as they age. Light is beautiful but temporary. Gravity, on the other hand, never leaks away. Mass stays, and every time one black hole merges with another, almost all of the mass remains inside the final object. Very little energy is lost. Over the span of billions of years, this imbalance becomes dramatic. The galaxy becomes fainter, the light spreads thin, but the weight of the black hole grows more and more intense. In Holm 15A, gravity has won this long, slow cosmic contest. The black hole at the galaxy's center has grown so heavy that it dictates the behavior of everything in the inner regions. Stars that wander too close do not orbit the combined influence of millions of smaller objects, as stars do in most cores. Instead, they orbit a single dominant source, following paths determined almost entirely by its immense gravitational pull. Their speeds rise sharply as they approach the center, reaching velocities far higher than what the surrounding starlight would normally imply. In a typical galaxy, the influence of a central black hole might stop after a few light years. But in Holm 15A, the region where the black hole controls everything stretches across thousands of light years. Imagine that. a territory so vast that the black hole rules over not just the tight, dense clusters of stars nearest the centre, but also over enormous regions where the number of stars is low. Its gravity reaches outward like invisible hands, shaping orbits that would otherwise be dominated by the mass of the galaxy's core. It imposes its own structure on space, creating a gravitational landscape that only a truly ultramassive black hole can produce. This influence even shapes the physical form of the galaxy. The hollow core of Holm 15, so large that it challenges every intuitive sense of cosmic size, is a direct result of how the central black hole and its ancestors interacted with stars during past mergers. When two black holes spiral inward toward each other, they fling stars away with unbelievable force. These ejected stars leave behind a central cavity, a volume of space that stays empty. The stars cannot easily fall back in later because the gravitational environment has changed forever. That region remains faint, extended, and strangely smooth, a scar that never heals, a permanent imprint left behind by the violent marriage of supermassive objects. In a way, Holm 15A's structure is like a monument sculpted by subtraction. Instead of being carved by an explosion or by some colossal impact, it was shaped by the removal of stars, by the pushing away motion of the merging black holes at its heart. Even the galaxy's silence today, the absence of bright jets, glowing disks, or fierce bursts of energy, is part of this story. It reflects not weakness, but lack of fuel. And the black hole influences more than just stars. It shapes how gas moves within the galaxy, or more accurately, how gas fails to move. In calmer galaxies, gas can cool, drift inward, get compressed, and possibly form new stars. But in a massive cluster like Abel 85, that gas is cooked by the environment. The intracluster medium is heated to temperatures of tens of millions of degrees, kept hot by shockwaves, turbulence, and ancient episodes when active black holes once blasted enormous amounts of energy into their surroundings. Gas that hot cannot cool easily. It cannot sink inward. It is too energetic to settle into a disk. And so, even though the black hole in Holm 15A is huge, it receives little nourishment. It grows slowly now, not through bright accretion like the quasars that lit up the young universe, but through occasional mergers and the rare swallowing of an unlucky star that wanders too close. In many ways, Holm 15A is a fossil of a younger cosmos. It carries the memory of a time when galaxies slammed into each other much more often. It remembers an age when black holes were still growing explosively, when they were fed by rivers of cold gas, when the brightest quasars shone so fiercely that they could outshine entire galaxies. The present quiet is not a sign that the central black hole has run out of power. It is simply the sign that the universe around it has grown too old to feed it efficiently. It is the quietness of exhaustion, not emptiness. This leads to questions far bigger than Holm 15A alone. What sets the upper limit of how large black holes can grow? Could they grow even more enormous if conditions were right? How far can gravity push, and how much mass can be gathered before light, matter, and even theory itself begin to break down? Some scientists argue that ultramassive black holes like the one in Holm 15A are the natural outcome of repeated mergers in dense environments. If the universe were infinitely old, they might grow larger still. Others suggest that clusters eventually place a hard limit on growth. The stripping of gas, the heating of the cluster medium, and the lack of new material to fall inward all combine to starve the black hole. Holm 15 sits right at the intersection of these possibilities. It is heavy enough to challenge our assumptions, old enough to serve as a cosmic marker, and silent enough that we can study its gravity without the glare of strong radiation hiding the details. The presence of such a heavy black hole also forces us to adjust how we think about galaxies themselves. We often imagine galaxies as the main structures, with black holes acting like engines or regulators inside them. But Holm 15A flips that picture. Here, the black hole is not a secondary feature, it is the main feature. The galaxy around it is more like the leftover structure, the residue of billions of years of mergers that built the real heart of the system, the central black hole. This reversal changes the way we interpret the growth of the biggest galaxies in the universe. It suggests that in the most crowded environments, black holes can grow faster than the galaxies that host them. It suggests that some galaxies are not merely homes for their black holes. Instead, they are shaped around them, built by them, and controlled by them. This idea has major consequences for how we understand the history of the universe. In the early ages, black holes grew by swallowing huge amounts of gas, creating brilliant quasars that lit up the darkness. But as time passed, the universe settled down. Gas supplies dwindled, clusters formed, star formation slowed, the brightest engines shut off, leaving behind silent giants like the one in Holm 15A, relics of a cosmic transition, bridges between the universe's explosive youth and its more peaceful maturity. These giant black holes remind us that growth is not always smooth. Sometimes things grow quickly at first and then remain unchanged for a very long time. The black hole in Holm 15A appears to be one of the finishing points of such growth. Massive, dominant, and now resting in quiet darkness. But hidden in its mass is something even more profound. A black hole with more than 20 billion solar masses produces a gravitational environment that is different from anything we experience near smaller objects. The curvature of space is deeper, the horizon stretches wider, time itself slows dramatically near it. If a star wanders too close, the tidal forces would tear it apart long before it could cross the horizon, shredding it into a thin stream of glowing debris. Even that glow would be faint compared to the blazing quasars of ancient cosmic history. The scale of the event horizon is beyond human imagination. The horizon of Holm 15A's central black hole would span billions of kilometers. It would be large enough to swallow the orbits of planets if it were somehow placed inside our solar system. And yet, despite being so enormous, so heavy, and so fundamentally strange, it remains invisible. It sits more than 700 million light-years away, and from that distance it blends perfectly into the darkness. No telescope can photograph its outline directly. It does not shine. It does not reflect. It simply exists, hidden inside the glow of the faint galaxy that surrounds it. All we see is its influence, the motion of stars, the shape of the core, the faint stretches of the halo, but never the black hole itself. And in that contrast lies the deepest fascination. Something can be unimaginably large and unimaginably powerful, yet still forever invisible. Something can rule the space around it completely and still appear as nothing at all. Ultra-large black holes like the one inside Holm 15. Show us that the universe hides some of its greatest structures in plain sight, leaving only their gravitational fingerprints behind. A galaxy is always more than the stars we see shining inside it. It is more than a glowing collection of suns scattered across space. A galaxy is a memory. It is a vast, drifting record book that keeps every moment of its life written into its shape, its light, and the strange ways its stars move. Every collision it has ever endured, every quiet orbit traced by ancient stars, every disturbance that once shook its core, and every long, wordless night when nothing happened except the slow passage of time. These things are written into it as clearly as words are written into a story. Holm 15. One of the strangest galaxies ever found, carries such a record in the faintest possible way. When you look at it from a distance, you do not see the usual signs of a lively galaxy. There are no dramatic lanes of dust snaking across its face like dark rivers flowing between glowing regions. There are no bright clouds of hydrogen shining like neon lights. There are no arms of blue newborn stars curling and twisting with energy. Instead, what you see is a soft, smooth, ancient glow. The entire galaxy looks like an enormous ghost made of starlight. The glow is dim, stretched thin across an incredible volume of space, almost as if time itself had slowly eroded the galaxy, thinning it until only a pale memory remained. But this faint light is not weakness. It is age. It is the long, slow, patient glow of something that has lived through more turmoil than we can imagine. Holm 15. A is quiet, almost eerily silent when compared to most galaxies. But that silence is not emptiness. It is testimony. It is a sign of everything the galaxy has survived. Most galaxies spend billions of years making new stars. They glow with bursts of bright blue light from young, short-lived giant stars. They churn their gas into fresh generations of suns, building new structures layer by layer, century after century, age after age. But the galaxy we are speaking of stopped making stars long, long ago. Its gas, the raw material needed for star birth, was stripped away, heated until it could not cool down, or swallowed during the violent age of mergers that shaped the galaxy into what it is today. What remains now is a population of survivors. These are old stars, red and faintly glowing, drifting through the galaxy like dying embers floating upward from a fire that once burned far hotter. Each one of these stars is ancient. Each one carries the weight of time. Each one has been shaped by gravitational events far more powerful and dramatic than anything humanity has ever witnessed. These stars are the children of galaxies that no longer exist, galaxies long consumed and absorbed into the enormous body of Holm 15A. When you look closely at the light of Holm 15A, you notice something that does not happen in most galaxies. Usually the light becomes brighter and brighter as you move toward the center. That is what we expect. The majority of stars crowd into the middle, creating a bright, glowing core. But here, the brightness does not climb sharply. Instead, it softens, then flattens, and then, quite surprisingly, it dips into a gentle darkness. It looks almost as if the center has been hollowed out, carved into a vast empty cavity, where once there should have been a dense crowd of stars. This is not imagination, it is real. The hollow core is one of the signatures of something extraordinary. The scouring action of binary black holes. In the far distant past, when enormous galaxies collided and merged, their supermassive black holes fell toward one another and formed a binary pair. As these black holes spiraled around each other, they acted like a gravitational bulldozer. They flung stars out of the center, ejecting them into wider orbits or hurling them out of the galaxy entirely. They carved out the heart of Holm 15A. They scoured away the stars that once lived there, leaving behind a region so depleted that even after billions upon billions of years, the stars have never returned. They cannot return. Their orbits were changed too much. The gravitational field inside the hollow core does not allow stars to drift back in easily. The hollow space is permanent. It is a fossil, a leftover imprint of ancient encounters between black holes far more massive than anything near our own Milky Way. Yet, the outer halo of the galaxy tells a very different story. It stretches smoothly outward, spreading across hundreds of thousands of light years, becoming fainter and fainter until it blends into the general glow of the surrounding galaxy cluster. This outer envelope of stars holds the remains of galaxies long gone. Streams of stars torn from small companion galaxies form faint arcs and rivers that melt into the overall glow. Their shapes have long dissolved, erased by the restless gravitational forces within the cluster, but their existence reveals the galaxy's appetite. Holm 15. A has consumed many smaller neighbours over time. Each galaxy it swallowed contributed more stars to the faint halo, adding layer after layer to the enormous shimmering sphere of ancient light. Each one was pulled inward by the deep gravitational well at the galaxy's core, disappearing into the larger body like drops of water sinking into a vast dark ocean. The stars in this giant envelope do not move in neat, orderly rotations. They drift like a cloud of dust blown by an ever-changing wind. Each star follows a path influenced by the violent past of the galaxy. Some stars swing in great looping arcs that circle the galaxy in broad, stretched-out ellipses. Others fall inward toward the center and then swing back outward. Many follow chaotic, unpredictable routes, never repeating the same loop twice. Their motions are not the smooth harmony found in spiral galaxies, but the chaotic dance of memory written into gravity. Every movement is shaped by scars left behind from ancient collisions and black hole encounters. This is what makes Holm 15 such an extraordinary laboratory for astronomers. In most galaxies there is order. Stars move in clearly defined patterns, gas flows along predictable paths, and structures like spirals and bars reveal the history of star formation. But in Holm 15A, structure has dissolved into something else. Its dynamics do not reflect calm, organized growth. They reflect the violence that shaped it. Over the course of billions of years, a process called relaxation tends to smooth out chaos. Random motion becomes more orderly. But even after all this unimaginable time, the motions of the stars still show faint traces of past turmoil. The galaxy's memory refuses to disappear entirely. Its stars carry complexity. They carry echoes of old disturbances. They carry the fingerprints of everything that came before. The environment around Holm 15. A plays a huge role in shaping it. The galaxy lives in a place called the Abel 85 cluster, and this region is anything but gentle. It is crowded with galaxies, filled with dark matter, and drenched in superheated gas that flows between galaxies like a slow-moving cosmic ocean. Every star inside Holm 15A is influenced not only by the galaxy's own gravity, but also by the pull of the entire cluster surrounding it. The cluster's gravitational field is carved by dark matter, an enormous invisible halo far larger than all the stars and gas combined. In such an environment, the outer edges of Holm 15A blend into the cluster almost seamlessly. Its halo dissolves into the larger gravitational field, making it nearly impossible to say where the galaxy ends and the cluster begins. It is not an isolated creature drifting alone in space. It is a central organ in a much larger cosmic body. Because it is deeply embedded within the cluster, Holm 15 cannot be understood by looking at it alone. Its stars are constantly stretched and tugged by tidal forces, the subtle gravitational stretching caused by the cluster's enormous mass. These forces smooth out small structures, erase delicate features, and help create the vast, diffuse envelope of light we observe today. Over billions of years, all these influences have turned Holm 15A into something unusual. It is less like a typical galaxy, and more like a gravitational imprint of the cluster's entire history. Its faint halo contains stars from galaxies that ventured too close, from companions that passed through its outskirts, from structures torn apart before they had a chance to settle. Inside the hollow core, the stars behave differently from the ones in the outer regions. The core is not completely empty, but it is astonishingly sparse. The density of stars is far lower by orders of magnitude, than what we find in normal galactic centers. The stars that remain in this region do not move in tight, crowded paths. They drift far more freely. Their orbits are shaped mainly by the gravitational pull of the supermassive black hole at the center. As they move closer to the central region, where the black hole's influence becomes absolute, their speeds increase dramatically. Their paths are controlled not by the mass of the galaxy as a whole, but by the very shape of space-time around the black hole. This is why the core looks so faint. There are simply too few stars there, and those that remain move too quickly and too sparsely to create the bright, concentrated glow we normally see in elliptical galaxies. The hollow center exists because binary black holes long ago swept through this region and removed enormous numbers of stars. And the strange geometry of the space around the central black hole prevents new stars from wandering back in easily. The result is a delicate but permanent balance between absence and dominance, a balance that gives Holm 15A its unusual appearance. Even the colour of the galaxy offers clues to its strange life. Its reddish hue tells us that its stars are old, aging, and slowly fading. It is the colour of a galaxy that has not made new stars for a very long time, a galaxy that has lived through ancient violence and settled into a state of quiet endurance. Holm 15 is a galaxy whose stars shine with a deep reddish glow, the kind of soft and ancient light that comes only from very old stars. In most galaxies, bright blue stars burn fiercely and die young, living fast and ending quickly in explosions or fading into darkness. But in Holm 15, the blue stars are long gone. Only the older, calmer red stars remain, glowing like embers in a fire that once roared, but now burns low and steady. This simple fact tells us something remarkable about the galaxy. It has been quiet for many billions of years. It has not made new stars for an extremely long time, meaning that whatever cold gas it once had, the gas needed to create fresh stars, has disappeared. It has either been used up long ago, heated to such high temperatures that it can no longer cool and collapse, or stripped away by the strong gravitational tides inside its enormous galaxy cluster. This absence of youthful stars does not mean that Holm 15 is falling apart or becoming lifeless. Instead, it reveals a different kind of beauty and a different stage of life. This is a galaxy that has reached maturity, a galaxy that has moved past the turbulent days when it collided with neighbours, swallowed smaller galaxies and formed new stars at a furious pace. Holm 15 has completed the main journey of its evolution. What remains now is a long, quiet and graceful chapter, marked not by new creation but by the steady glow of ancient starlight. Inside the galaxy, the movement of material is astonishing in its precision. Every star, every cluster, and every orbit moves in a kind of perfect gravitational balance, as if the entire system has settled into a cosmic dance that took billions upon billions of years to choreograph. The outer halo of the galaxy, the faint outer envelope of stars, is shaped not only by the galaxy itself but by the immense tidal forces of the surrounding cluster, known as Abel 85. These tides stretch and pull softly at Holm 15, giving the galaxy its outer form. Deep inside, the story changes. The inner region of Holm 15 is shaped by the enormous supermassive black hole at its centre. This black hole is so massive and so influential that it bends the paths of nearby stars, dictating how they move, how they orbit, and how they drift across space. Between the outer influence of the cluster and the inner pull of the black hole lies a fascinating transition zone. In this region, the stars are not ruled by just one force but by all three at once: the mass of the galaxy itself, the tidal field of the cluster, and the gravity of the central black hole. Stars in this in-between place move in orbits that feel all these influences at the same time. They are not so close to the core that the black hole dominates, and not so far out that the cluster's tides take over. Their motions are a blend of everything, creating a layered, intricate gravitational structure. This structure is not messy or disorganized. It is not chaotic. It is a carefully balanced arrangement, a living record of the galaxy's entire history. The way the stars move today carries the memory of every past collision, every ancient encounter, every period of violence, and every moment of calm. Holm 15, in many ways, exists in a kind of cosmic twilight. It still shines, but its glow is soft and subdued. It still moves, but slowly, as though the whole galaxy has entered a long evening after a day filled with storms and sunlight. Its structure is no longer being shaped by new explosions or sudden bursts of starbirth. Instead, it is shaped by the quiet settling of events that happened countless ages ago. The galaxy is stable, but never completely still. It continues to respond to the slow drift of other galaxies in the cluster, and the gradual changes in the enormous cloud of dark matter that surrounds everything. But at its heart, nothing new is forming. No fresh stars are being born. No bright youthful clusters light up the night. The central black hole, once a ravenous engine that devoured gas and produced blinding jets or flares, now sleeps in a long hibernation. This is what a galaxy looks like after the universe has sculpted it fully. All the wild shaping forces of its youth have passed. There are no bright starburst regions, no dramatic spiral arms filled with newborn stars, no violent eruptions as the black hole feeds. The galaxy instead glows with the dim, warm light of stars that have lived for billions upon billions of years. The light spreads gently across the immense space of Holm 15, like the final glow of a once blazing fire. Holm 15 carries memories written into its very shape. It remembers the smaller galaxies it consumed, the partners it collided with, and the storms of starbirth that once ignited its interior. Its present peace is not accidental. It is the result of ancient chaos that has long since faded, leaving only the quiet echo of those wild times behind. Yet even as Holm 15 drifts in this deep calm, the universe does not rest. Around it, the great cluster Abel 85 continues to evolve. New galaxies fall slowly into the cluster's immense gravitational well. Dark matter shifts and reshapes the entire region over unimaginable stretches of time. The hot gas between galaxies circulates like a silent ocean, flowing, heating, cooling and drifting. Cooling. Through all of this, Holm 15 remains steady and anchored, a quiet giant surrounded by the movements of younger, more active galaxies. Holm 15A is not a solitary wanderer in the vast cosmic ocean. No galaxy that resides at the heart of a massive cluster exists in isolation. Each one is entwined within a grander gravitational network, a complex structure far exceeding the size of any single galaxy. Holm 15. A is embedded within a gravitational environment of immense proportions, a cosmic basin meticulously shaped over billions of years. This basin, sculpted largely by the invisible hand of dark matter, is filled with the remnants of galaxies that have fallen inward over time, their forms distorted and consumed as they contribute to the evolving structure. The galaxy cluster known as Abel 85 is the stage on which Holm 15A has been moulded, not in a gentle cradle, but within a relentless furnace of cosmic forces. It is a place of transformation, where galaxies are stripped of their gas, heated to extreme temperatures, stretched by immense gravitational tides, and ultimately absorbed into larger systems. In this environment, gravity is far more dominant than identity. The universe here operates as a slow and deliberate architect, assembling structures of extraordinary scale with a pace that seems almost geological. A galaxy cluster is far more than a collection of galaxies gathered in proximity. It is a living, dynamic entity, its life governed by forces that are invisible yet omnipresent. Dark matter forms the hidden skeleton of this cosmic organism, providing the framework upon which the cluster's structure is built. Within this skeleton, hot gas fills the vast volumes, glowing faintly in X-rays, while galaxies drift like suspended organisms in a medium they cannot escape. Abel 85 is immense. Its dark matter halo extends hundreds of thousands of light-years from its center, containing far more mass than all the stars in the cluster combined. This unseen matter exerts its influence across the cluster, bending space itself, guiding the orbits of galaxies and controlling the flow of gas and stars. Without the presence of dark matter, the galaxies within Abel 85 would not remain bound. They would drift apart, carried away by the relentless expansion of the universe. Instead, they follow long, slow spirals inward, drawn by the cluster's gravity toward the central galaxy, Holm 15A. The journey inward is neither simple nor gentle. Galaxies entering Abel 85 experience forces far more extreme than anything they would encounter in isolation. As they plunge into the cluster, they encounter the intracluster medium, a vast expanse of gas heated to tens of millions of degrees. This searing wind strips the galaxies of their own gas in a process known as ram pressure stripping, removing the essential fuel for star formation. Spiral galaxies, which rely on their gas to create new stars, are the first to succumb. They lose their bright, youthful gas, becoming quiescent, red, and smooth. Smaller galaxies may be torn apart completely, leaving behind scattered clouds of stars that drift freely within the cluster. Even larger galaxies are not spared, surviving only as diminished shells of their former selves. By the time these galaxies reach the inner regions of Abel 85, they're already altered, weakened, and primed to merge with the central behemoth, Holm 15. It sits precisely at the confluence of these inward paths, at the very bottom of the cluster's gravitational well, where all matter ultimately converges. Galaxies are drawn toward it as inexorably as rivers flowing to the ocean, slowly, steadily, and stripped of much of what once defined them. The process of merging with Holm 15A is shaped by many factors. The mass of the incoming galaxy plays a role, but the tides of the cluster itself exert a profound influence. Gravitational forces stretch the galaxies, distort their shapes, and scatter their stars long before any final coalescence occurs. By the time a merger concludes, only the densest cores of the incoming galaxies remain as distinguishable structures, and even these are soon assimilated into Holm 15A. This environment encourages frequent mergers. In isolated regions of the universe, a large galaxy might experience only a handful of major mergers over its lifetime. In the rich, dense environment of Abel 85, Holm 15A has likely undergone many. These mergers, occurring over billions of years, are the primary reason for its colossal mass and its hollowed-out central core, a feature that marks it as one of the most extraordinary galaxies in the known universe. The cluster environment does more than deliver galaxies to Holm 15A. It actively suppresses the formation of new ones. The intracluster gas is too hot to collapse under its own gravity, remaining suspended in a diffuse glowing fog of plasma. Cold gas, the raw material for star formation, is exceptionally rare. As a result, star formation within the central galaxy is almost non-existent. Abel 85 does not create, it preserves or destroys. It is an environment that ends cycles rather than initiating them. This is why Holm 15A is dominated by ancient stars. The conditions of the cluster prevent the birth of new ones. Any gas that attempts to cool is reheated by shocks, turbulence, and the cluster's immense gravitational potential. In effect, the galaxy becomes a closed system, relying solely on the stars it already contains. This process is a form of cosmic aging, not decay, but a slowing of the vibrant processes that once fueled its growth. Star formation halts, gas accretion ceases, and the central supermassive black hole enters a dormant phase. The galaxy settles into a state of equilibrium, its evolution marked more by preservation than change. Even the motion of Holm 15 within its cluster tells a story of dynamic interaction. As the brightest cluster galaxy, It occupies the central position within Abel 85, yet it is not perfectly stationary. The galaxy drifts subtly within the gravitational potential well, responding to the movements of the cluster's dark matter and the gravitational influence of nearby galaxies. These motions are slight, often only tens or hundreds of kilometers per second, but they demonstrate that even the central galaxy is part of a larger, intricate cosmic dance. Nothing in the universe exists in isolation. Every object responds to forces far greater than itself, and Holm 15A is no exception. The galaxy's outer shape also bears the imprint of its environment. Its halo is stretched and diffused not by internal rotation, but by the tidal forces exerted by the cluster. Holm 15. A has no sharply defined boundaries. Its stars gradually fade into the ambient light of Abel 85, giving the galaxy a ghostly ethereal appearance, as though it is a memory rather than a concrete object. Its identity is not confined to its visible stars. It dissolves into the surrounding cluster, becoming part of a collective gravitational history that extends far beyond the galaxy itself. Dark matter is central to this identity. Though invisible, its influence is unmistakable. Observations of galaxy motion within Abel 85 reveal that the visible matter alone cannot account for the gravitational forces at play. Gravitational lensing of background galaxies exposes a dark halo with a mass far exceeding that of all the stars combined. This halo dictates how galaxies fall inward, how mergers unfold, and how Holm 15A accumulates its mass. Without dark matter, there would be no central giant galaxy, no hollow core, no ultramassive black hole. Dark matter builds the stage while gravity choreographs the intricate ballet of matter upon it. Even in this dense and violent environment, growth is not infinite. There is a natural limit to what the cluster can provide. Many of the galaxies that once fed Holm 15A have already been absorbed, stripped, or disrupted beyond recognition. The core of the cluster is relatively quiet now. The remaining galaxies orbit at greater distances, tracing long paths that may never bring them into direct interaction with the central giant. Holm 15. A has entered a new phase of its life, one in which growth slows, mass stabilizes, and the galaxy becomes less a site of construction and more a monument to the work that has already been done. The cluster has not only shaped Holm 15A in the past, it continues to shape its future. A galaxy that once grew rapidly now does so at a glacial pace, and a supermassive black hole that once feasted on infalling gas and merging galaxies now waits, perhaps indefinitely, for events that may never arrive. The cluster itself continues to evolve, its motions and transformations ongoing, yet the tempo has changed. The tumultuous youth of the galaxy and the cluster has passed. A quiet middle age has arrived. Despite the stillness of this era, the history of Holm 15A and Abel 85 remains visible, encoded in subtle but unmistakable ways. The intracluster gas carries the echoes of ancient supernovae and past activity from black holes. Streams of stars stripped from countless mergers form the extended halo of Holm 15A. The velocity dispersion of stars near the galaxy's centre betrays the presence of the ultramassive black hole lurking there. The gravitational potential of the cluster itself reveals the structure of dark matter, sculpted over billions of years by the relentless evolution of the cosmos. Each feature of Holm 15A is a record, a memory written not in words or images, but in the scars left by gravity and time. The faintness of its stars is a testament to the loss of gas. The smoothness of its halo reflects the stretching and tearing of tidal forces. The emptiness of its core signifies the presence of black hole binaries, and the quietude at its centre speaks to the aging of a universe once dominated by frenetic activity. Yet to fully comprehend the fate of Holm 15A, one must look beyond its present stars and the immediate cluster environment. The ultimate story of such a galaxy lies in the cosmic future. What happens to a galaxy when it no longer produces new stars? What becomes of its central black hole when it ceases to grow? What is the destiny of a galaxy as the universe continues to expand and the cluster becomes increasingly isolated from its surroundings? The answers are found not only in what Holm 15A has been, but in what it is slowly becoming. Its story is one of ancient collisions, violent growth, and gradual quieting, played out over billions of years against the backdrop of a universe drifting towards silence. The galaxy that was once a hub of cosmic activity now transitions into a monument of accumulated history, a repository of gravitational memories, and a witness to the long and measured passage of time in a cosmos that moves inexorably forward. The central black hole of Holm 15A, now dormant, represents the culmination of this long history. Once it was fed by streams of gas and the cores of merging galaxies, growing to unimaginable proportions, influencing the very structure of its host galaxy. Today, it waits in relative stillness, a sentinel at the heart of a galaxy shaped by forces far larger than itself. Surrounding stars and the diffuse halo carry the memory of the black hole's past influence, evidence of energy injected and matter redistributed across vast scales. Even as Holm 15A's growth slows, its central black hole remains an enduring presence, a silent guardian of the galaxy's ancient dynamism. In the long-term cosmic future, Holm 15A may become increasingly isolated, as the expansion of the universe pulls distant clusters and galaxies away from one another. Its environment will continue to influence it, though perhaps more subtly, as fewer mergers occur and the intracluster medium gradually cools. The galaxy's stars will age, evolving into cooler, redder forms, and the diffuse halo will persist as a testament to the countless interactions that built it. Its central black hole will persist as a colossal, yet inactive entity. Holm 15 thus stands as a monument not only to its own history, but to the evolutionary processes that govern galaxy clusters as a whole. It is a galaxy that remembers in the faintest light and in the motions of its stars the story of a universe that has aged and will continue to age over incomprehensibly long timescales. Every detail of Holm 15A tells a story. The faint glow of its outer halo speaks of stars that once belonged to other galaxies, stripped away and added to the central giant over billions of years. The smoothness of its stellar distribution reflects the immense tidal forces that have shaped the galaxy, stretching and blending its stars into a diffuse envelope. The hollow core hints at the violent interactions of supermassive black holes, evidence of the galaxy's tumultuous mergers and the gravitational scouring that followed. Even the subtle drift of Holm 15A within the cluster's gravitational well conveys the dynamism of the system. Each aspect of the galaxy is a page in a history written by gravity, dark matter, and cosmic evolution, and each reveals the cumulative effects of billions of years of galactic life. Ultimately, Holm 15A is more than the sum of its stars, more than the product of its collisions, and more than the resting place of an ultramassive black hole. It is a record of the cluster's history, a reflection of the dark matter that dominates its surroundings, and a testament to the slow, inexorable processes that govern the growth and evolution of the universe's most massive galaxies. Abel 85 shaped it, guided it, and continues to influence it, creating a galaxy that is at once a monument, a memory, and a living, breathing participant in the cosmic ballet. As the universe marches onward, expanding and evolving, Holm 15A remains a symbol of the enduring power of gravity, the unseen influence of dark matter, and the remarkable complexity of galaxy clusters. Its story is one of creation and destruction, of violent growth followed by quiet stability, and of a universe that, over billions of years, has moved toward both structure and silence. Holm 15A's journey is far from unique, yet it is exceptional in its scale and clarity. The galaxy embodies the processes that shape the most massive galaxies in the universe: mergers, tidal interactions, stripping, and the persistent guidance of dark matter. Its core, hollow and vast, tells of a history dominated by black hole interactions and the assimilation of smaller galaxies. Its halo, extended and diffuse, records countless tidal encounters. Its dormant black hole speaks of an earlier era of energetic activity, while its stellar population reflects the cessation of star formation caused by the extreme environmental conditions of its cluster. The galaxy stands at a crossroads between its violent past and its quieter future, an artifact of processes that unfold over timescales far beyond human comprehension. It is a monument to the patient and persistent forces that shape the universe, a testament to the way matter responds to gravity, and a witness to the inexorable passage of cosmic time. In the end, Holm 15A is a galaxy defined less by its visible stars and more by the vast invisible forces that govern its environment, Its story is intertwined with that of Abel 85, a galaxy cluster dominated by dark matter, searing intra-cluster gas, and the slow, inexorable inward fall of countless galaxies over billions of years. Every aspect of Holm 15A, the faint glow of its stars, the hollow of its core, the subtle drift within the cluster, and the presence of its ultra-massive black hole, is a chapter in a history written by the forces of the universe itself. To study Holm 15A is to witness the slow dance of gravity, the quiet but persistent influence of dark matter, and the remarkable processes that govern the life cycle of the largest galaxies. Its destiny, like its past, is bound to the cluster that surrounds it, a destiny that unfolds on scales both immense and almost imperceptibly slow, marking the galaxy as one of the most extraordinary objects in the cosmos, a living record of cosmic evolution and gravitational history. Holm 15 is, in every sense, a galaxy that remembers, not through images or light, but through the distribution of its stars, the motion of its core, the silence of its central black hole, and the diffuse glow of its extended halo. It is a record of billions of years of collisions, mergers, tidal interactions, and environmental influences. The faint stars, the smooth halo, and the hollowed core all encode the narrative of a universe in which gravity and dark matter are the ultimate authors. In this galaxy, every star, every stream, every motion is a memory, a record of the immense and patient work of the universe. It is a monument to the forces that shape the cosmos, an archive of ancient activity, and a witness to the long, slow evolution that continues to this day. Holm 15 and the cluster that nurtured it tell a story not of fleeting moments but of the enduring, patient and inexorable passage of time on a cosmic scale. The story of Holm 15 is not simply one of the past, told through the scars left by collisions and cosmic upheavals. It is also a story of the future, a narrative shaped by the patient and inexorable march of time across the universe, a time that drifts steadily towards silence. In the grand expanse of space, galaxies do not remain static. They grow, they interact, they merge and fade, weaving a complex web of motion and transformation. Yet, there comes a point in their existence when the violence of these events ceases to dominate their fate. Their evolution no longer hinges on fiery collisions, frenzied bursts of star formation, or the chaotic infall of neighbouring systems. Instead, they are governed by the slow, persistent flow of cosmic time, an invisible tide that shifts the universe imperceptibly but relentlessly. Holm 15. A has reached this era. It has emerged from the tumult of its youth into a phase of profound stillness. It no longer forms stars from cold gas clouds. It no longer feeds on the remnants of other galaxies or swallows matter in dramatic mergers. It has transcended the violent processes that once defined its growth. What remains is something entirely new, a stable, massive island in a universe that is steadily stretching away from itself, expanding into ever greater emptiness. In the coming billions upon billions of years, Holm 15. A will still feel the gentle gravitational tug of the galaxy cluster Abel 85 that surrounds it. But as the universe continues to expand, these pulls will weaken, becoming ever fainter as the space between clusters stretches and the cosmic web loosens. The dark matter halo, an invisible cocoon that binds Abel 85 together, will endure, resisting the expansion of space. Such a dense gravitational system cannot be torn apart simply by the stretching of the cosmos. Yet the filaments connecting it to the rest of the universe will thin, becoming fainter and more isolated. Over unimaginable stretches of time, only the densest knots of matter, such as Abel 85, will persist, standing as islands of gravity in an ocean of near-complete emptiness. Holm 15. A will reside at the heart of this knot, no longer a luminous giant but the oldest survivor of the once constant influx of matter that once poured into it. The stars within Holm 15. A will continue their slow aging. Red giants will shed their outer layers, creating ethereal planetary nebulae that glow faintly for a time before dispersing into the sparse environment. White dwarfs will cool gradually, becoming black dwarfs, cold and dark remnants of stars that once burned with intense nuclear fire. This process will not occur suddenly but steadily, patiently over trillions of years. The glow of Holm 15. A will fade imperceptibly as every stellar ember dims, until the combined light of its stars falls below what any biological eye could perceive. Eventually, the galaxy will become almost invisible, discernible only by the most sensitive instruments capable of detecting the faintest traces of light. Even these traces will eventually die, leaving the galaxy in darkness. Yet despite this fading, the gravitational shape of Holm 15A will remain. Stars do not vanish when their light does. They continue their orbits, their mass continues to influence the system, and they continue to hold the galaxy together. Time will subtly alter the trajectories of these stars. Without the birth of new stars, without inward-flowing gas, without any energetic sources to disturb them, the stellar system will slowly relax. Orbits will stretch and elongate. Some stars, nudged by gravitational interactions with others, will drift outward into the outer halo, or escape entirely into the intracluster medium. Others will gradually sink inward, drawn by the relentless pull of the ultramassive black hole at the galaxy's centre. Even this black hole, though it will no longer shine with accretion flares or display luminous disks of infalling gas, will continue to grow, albeit extremely slowly. Every particle, every stray star, every remnant wandering too close on a decaying orbit will add an almost imperceptible amount to its mass. Growth will be agonizingly slow, yet in the context of cosmic time, which stretches beyond imagination, even this painstaking process leads to enormous change. Over spans of time too vast for human minds to truly comprehend, the black hole could increase by millions or even billions of solar masses simply through these cumulative captures and mergers. Yet this growth will not be mirrored by the galaxy itself. The ratio of black hole mass to stellar mass will climb ever higher. The black hole, already among the heaviest ever detected, will assert ever more dominance. Its sphere of influence may stretch farther as the stars drift outward, becoming sparse and more tenuous. In the distant future, Holm 15. It may appear less like a traditional galaxy, with a central black hole, and more like a black hole surrounded by a faint halo of stellar remnants and orbital debris. It will be a ghostly shadow of its former self, a monument to time, rather than a beacon of light. The environment of Abel 85 will evolve alongside its central galaxy. Though the cluster will remain gravitationally bound, the galaxies within it will lose energy slowly through dynamical interactions. Over the next trillions of years, the cluster will experience a slow inward migration. This will not occur as a violent collapse, but as a gradual settling. Smaller galaxies, influenced by the subtle effect of dynamical friction, will drift inward, drawn toward Holm 15A. Some will eventually merge with the central galaxy, joining its halo as subdued additions. Others, however, will be torn apart long before reaching the core, their stars and remnants dispersed into the cluster's diffuse environment. Over unimaginable timescales, the cluster will simplify, becoming quieter, calmer, increasingly dominated by its central mass. The intracluster medium, the vast thin plasma that fills the space between galaxies, will cool extremely slowly. Yet this cooling will never reach the point necessary to reignite star formation. As the universe expands, the temperature of background radiation will continue to drop, making the cooling of hot plasma even more difficult. This intergalactic soup will remain a faint X-ray glow for durations beyond human imagination, slowly thinning as cosmic expansion stretches it further and further, but never condensing into new stars or galaxies. In the extreme, distant future, far beyond any age that humanity could conceive, most stars in Holm 15A will be dead. Some may collide, forming new compact remnants. Some may be expelled entirely from the cluster, wandering through the emptiness of intergalactic space. The light of the galaxy will gradually disappear, leaving only a structure detectable through its gravitational pull. Its mass will persist, its overall shape will remain, but its visibility will vanish. Holm 15. A will become a dark giant, an unlit fossil drifting in isolation within a cluster it once illuminated. The ultramassive black hole at its centre, though quiescent today, will endure as the most lasting component of the galaxy. In the grand scale of time, black holes emerge as the ultimate survivors of cosmic evolution. Galaxies may fade, stars may cool, gas may disperse, but black holes persist. They evaporate only through processes so slow that even the current age of the universe is insufficient to produce significant change. For a black hole as colossal as the one in Holm 15A, evaporation via Hawking radiation would take an interval vastly exceeding the age of the universe multiplied many times over, an interval so enormous that human language strains to describe it. This central darkness will survive everything else around it, enduring long after light and heat have vanished from its galaxy. Such endurance points to a strange, haunting future. Holm 15. A, once a luminous collector of galaxies, will eventually become a gravitational museum of relics. The remnants of dead stars, wandering stellar corpses, halo debris, and other scattered matter will orbit a central object of unimaginable mass. The dark matter halo that envelopes Abel 85 will persist as well, a silent cocoon preserving the shape of the cluster long after light has disappeared from most of its components. Yet even in this ultimate darkness, motion will continue. Gravity never rests. Remnant stars will continue to orbit the central black hole, slowly adjusting their paths. The black hole in turn will dominate the dynamics of the system, its influence expanding as time stretches onward. The cluster will gradually settle, as galaxies drift deeper into the gravitational well carved by Holm 15A. The story of Holm 15A will not end abruptly. It will dissolve into silence in the same gradual, unhurried way that it faded from light. In a future so distant that the universe has expanded beyond recognition, when no galaxies outside Abel 85 are visible, Holm 15, A will remain part of the last accessible island of matter within the cluster. Everything else will have receded beyond the cosmic horizon, slipping from view, unreachable, and effectively erased from observable reality. Within this isolated enclave, Holm 15A's central black hole may stand as the most massive gravitational source left. The galaxy, skeletal and faint, will continue to orbit it indefinitely. Even without shining stars, the mass of these remnants will still bend space, preserving the curvature dictated by the central darkness. This is the fate awaiting galaxies that survive long enough. Their light will dim, their forms will soften, and their black holes will become the longest-lived features of their existence. Holm 15. A is already on this path. Its violent youth is behind it, and it has entered a long cosmic twilight, a time when memory outweighs motion, when equilibrium shapes structure, and when the legacy of past mergers is etched not in brightness, but in emptiness. Yet this quiet future does not diminish the galaxy's significance. On the contrary, it magnifies it. A galaxy that has witnessed the universe's most extreme and violent epochs will become a serene record of those times. Its hollow core, carved by ancient collisions, will stand as a testament to the cosmic battles fought for space and resources. Its ultra-massive black hole will serve as a monument to the universe's capacity to create extremes and then allow them to rest. To truly appreciate Holm 15A, one must step back not into the past or the distant future, but into its present essence. Its core hollow is far more than empty space. It is a signature of gravitational sculpting unlike anything else in the nearby universe. It speaks to the forces that have shaped galaxies over billions of years, the slow accumulation of mass, the consumption and scattering of stars, and the delicate interplay of cosmic gravity. It is a relic, yes, but also a statement of power, endurance, and quiet dominance. The hollow is a silent monument, a record of the violent youth of a galaxy that has now embraced stillness. In the chapters ahead, we will explore this hollow itself, how it formed, what it signifies, and why its size challenges everything we expect about the shape and nature of massive galaxies. Holm 15 stands as a bridge across time, between chaos and quiet, between light and darkness, between growth and endurance. It tells a story not only of what has happened, but of what will inevitably unfold across the vast and patient cosmos. It is a galaxy that has completed the most tumultuous phases of its life, and yet its narrative continues, written in orbits, shadows, and the slow drift of matter under gravity's inexorable hand. Its legacy is measured not in luminosity or activity, but in survival, in persistence, and in the silent, enduring presence of a black hole that will outlast the stars, the gas, and even the light itself. Holm 15. A is already on this path, and it will remain, for as long as the universe allows, a profound testament to the deep and quiet power of cosmic time. The strangest and most remarkable feature of Holm 15A is not something immediately visible, like its vast size or its staggering mass. It is not even the ultramassive black hole that dominates the very centre of the galaxy, a black hole so enormous that its pull stretches across tens of thousands of light years, controlling the motion of stars and shaping the galaxy itself. What truly sets Holm 15A apart, what makes it stand out among the billions of galaxies scattered across the cosmos, is a hollow, a cavity so vast, so extraordinarily smooth, and so eerily silent that it seems less like a typical galactic feature and more like a geological monument carved directly into the starry fabric of the universe. It is as if some cosmic sculptor had reached into the galaxy and removed matter with such care and precision that the emptiness itself became the most striking aspect of the galaxy. In the universe, hollows of this scale are exceedingly rare. They do not arise from random processes or simple chance. They are not the result of galaxies left untouched by the violent forces that shape the cosmos. Instead, such hollows are the unmistakable signature of deep, long-lasting gravitational interactions that stretch across billions of years. They are the echoes of ancient events, preserved in the silence of empty space. Most galaxies draw the eye inward toward the centre, where stars are densely packed, glowing in a brilliance that floods every direction. In most galaxies, the centre is a luminous beacon, a swirling maelstrom of starlight and cosmic energy. Holm 15A is profoundly different. The closer one moves toward its centre, the less light there seems to be. The brightness does not increase as expected. It softens, flattens, then declines, fading into a dimness so complete that it almost feels unnatural inside a galaxy of this magnitude. This hollow is not merely a shallow depression or a slight thinning of the stellar population. It is a true absence. It is a void carved out with remarkable precision, a place where the density of stars falls to levels so low that one could traverse tens of thousands of light years and encounter only a handful of lonely, exhausted stars drifting slowly along elongated, lonely orbits. To understand how such a hollow comes into existence, one must think of a galaxy not as a static object frozen in space, but as a living gravitational system, a vast, dynamic well shaped by motion, attraction and collision over the course of cosmic history. In the early stages of Holm 15A's life, when it was still settling at the heart of the massive galaxy cluster known as Abel 85, other galaxies fell inward toward the cluster's centre. Each galaxy carried its own black hole, small or large, a dense knot of gravity at its core. When these galaxies arrived, their black holes sank toward the centre of Holm 15A, pulled inward by the inexorable force of gravity. Eventually, pairs of black holes met and formed binaries, tightly bound duos circling each other in a violent gravitational dance. These binaries became incredibly efficient machines, capable of reshaping the galaxy on enormous scales. They ejected stars from the core using nothing more than gravity itself. Any star that ventured too close to the binary would be flung outward at incredible speeds, accelerated like sparks thrown from the edge of an invisible wheel. With each encounter, stars were pushed away, forced into new orbits, or entirely expelled from the galaxy, sent into the surrounding cluster as intergalactic wanderers. Over billions of years, as this process repeated with each successive galaxy merger, the hollow grew. Each new pair of black holes added its own gravitational push, enlarging the cavity and scattering stars outward in all directions. The result was a smooth, expansive void, a space devoid of the chaos and irregularities that typically accompany violent events. If the hollow had been formed by explosions, stellar collisions, or bursts of gas from active galactic nuclei, one would expect asymmetries, clumps, and irregularities scattered throughout the core. Instead, the hollow is astonishingly round, ordered, and mathematically clean, an absence created not through destruction but through careful subtraction. It is a hollow carved by gravitational precision rather than explosive violence. The stars that once filled this space did not vanish or get consumed. They were not obliterated or erased from existence. Instead, they were accelerated, shifted into new trajectories, or expelled entirely from the galaxy. Some now drift alone through the vast stretches of the Abel 85 cluster, moving through the hot plasma that permeates intergalactic space, bound to no single galaxy, completely homeless in the cosmic expanse. Others were sent into the outer halo of Holm 15A, tracing faint tails and graceful arcs that gradually dissolved into the diffuse, ghostly glow surrounding the galaxy today. The hollow is also impressively vast. Its radius extends across tens of thousands of light-years, far exceeding the core of any typical elliptical galaxy. Only a handful of galaxies in the known universe possess cores even approaching this size, and even those pale when compared with Holm 15A. Most of the famous core galaxies have hollows measured in hundreds or perhaps a few thousand light-years. Holm 15A's hollow is nearly an order of magnitude larger, a cavity so immense that the central bulge of our own Milky Way galaxy could fit comfortably inside it with room to spare. Within this hollow remains a sparse population of stars, old and weary, moving under the commanding influence of the central black hole. These stars follow elongated, high-speed paths, rarely coming near one another. Their motions tell the story of the black hole's domain, not as a small region immediately surrounding the event horizon, but as a voluminous structure spanning thousands of light-years. In Holm 15A, the hollow is the blueprint of the black hole's power, a clear map of the limits of its gravitational control. But the hollow reveals more than just the presence of a supermassive black hole. It also speaks to the limits of galactic growth and evolution. In galaxies with ordinary central densities, binary black holes can excavate cores only up to a certain size. Beyond that, stars become too sparse for efficient ejection. Without enough stars passing near the central binaries, the black holes lose their ability to continue the slingshot process, and merging stalls. In many cases, additional galaxies or dense clouds of gas are needed to complete the merger and sustain the core excavation. Holm 15. A, however, occupies a unique environment. Its location within the densely populated Abel 85 cluster meant that mergers continued far beyond typical expectations. Each collision brought in new stars, fresh black holes, and renewed gravitational energy. Every time the hollow began to refill, another galactic encounter swept through, clearing it once again. The hollow thus became a layered record of repeated gravitational scouring, a pale archive etched in the absence of matter itself. Eventually, the hollow reached a scale where repopulation became impossible. The central black hole grew to such an immense size that its influence dominated the local gravitational environment entirely. Stars that passed through the hollow had their orbits stretched, twisted, and redirected. The core became a region where gravity governed far more strongly than starlight, a domain ruled by unseen forces rather than luminous matter. The hollow ceased expanding not because the process ended, but because the supply of incoming galaxies slowed, the cycle of mergers and ejections diminishing naturally with time. The hollow is the endpoint of a long gravitational cascade, a final equilibrium shaped by the history of central black holes and the relentless pull of gravity. Even now, the hollow is not completely static. Stars drift in and out, following elongated paths that carry them toward the center, before flinging them outward again. Some stars gradually lose energy and edge closer to the black hole, while others gain energy through subtle interactions, moving outward toward the faint halo of the galaxy. Despite these ongoing motions, the hollow maintains its structure. It remains smooth, dim, and extended, a memory of space carved by the absence of matter. There is something almost philosophical about such a hollow. It represents not a failure of creation, but a record of it. Galaxies are built through accumulation, through the gradual gathering of stars, gas, and dark matter. But accumulation does not always result in filling. It can also lead to subtraction. Growth can bring about excavation, and creation can create emptiness. In the case of Holm 15A, we see an extraordinary example of this principle. A galaxy that has grown through mergers, collisions, and the inexorable pull of gravity has also been hollowed out, shaped as much by what is missing as by what remains. The smoothness of the hollow is particularly striking, like a cosmic work of art. It is round, perfectly symmetrical, and almost eerily calm. Unlike many galactic features which carry scars of their violent pasts in twisted filaments or clumped star clusters, the hollow in Holm 15A is clean and uncluttered. It tells us that the forces at work were not random, not chaotic. Instead, they were precise, systematic, and repeated over unimaginable spans of time. Stars were not destroyed but removed. Matter was not annihilated but rearranged. The hollow is a testimony to the invisible but powerful hand of gravity, sculpting a void in the midst of one of the largest galaxies known. Looking at Holm 15A, one cannot help but be awed by scale. Tens of thousands of light-years of emptiness shaped by ancient binaries and driven by the inexorable march of gravitational physics dwarf even our most ambitious galactic imaginings. It is a place where the absence of stars speaks louder than their presence, where darkness and emptiness are not signs of decay but of cosmic history recorded in a unique, elegant and haunting way. The hollow is a monument to cycles of accumulation and subtraction, to the rise and fall of stars under the relentless dominance of black holes, and to the immense patient power of gravitational forces working over billions of years. It is both a physical space and a narrative of cosmic time, telling the story of how galaxies evolve, how black holes shape their environments, and how absence itself can define structure. It is a void, but it is full of meaning, history, and the echoes of ancient cosmic processes that continue to unfold today. Holm 15 reminds us that the universe is not merely a place of light and matter, but also of emptiness. In its hollow, we see the elegance of gravitational physics, the traces of ancient mergers, and the quiet dominion of a black hole whose influence stretches farther than our imagination can easily grasp. The galaxy is not just a collection of stars, it is a record of cosmic engineering, a silent testament to the ways in which growth, accumulation, and repetition can paradoxically create the emptiest of spaces. The hollow is an archive, a blueprint, a monument, and a mirror, reflecting the strange beauty of a universe that is constantly building and simultaneously subtracting, shaping matter and space through forces that operate on scales beyond human comprehension. A hollow is never truly empty. It is a place where everything that once had a presence has been shifted, pushed aside or absorbed to make room for something far heavier, far denser, and far more commanding. In Holm 15A, this hollow is not simply a void, a space without content. Instead, it is a silent monument to the invisible force that shapes everything in its path: gravity. The cavity at the heart of this galaxy is not meant to be dramatic to the human eye. From our distant vantage on Earth, it seems almost gentle, a faint dip in light, a soft indentation in a sea of starlight that spreads across the galaxy. Images of it suggest only a mild shadow, nothing spectacular, nothing to suggest the staggering power that truly resides there. Yet, if one could somehow stand upon a star within that hollow, a lonely metaphorical position, for the stars that survive there are too few and too dim to be seen, one would encounter a reality far beyond ordinary comprehension. The very fabric of space would be subtly warped around you. The curvature of space, though invisible, would make itself known in the delicate shifts of every orbiting star. Distances would behave strangely, stretching and compressing in ways that defy direct perception. Time itself would flow differently, ever so slightly inside this immense gravitational cradle. You would not merely be in space, you would be inside a vast gravitational engine, a force that has persisted quietly and relentlessly for billions of years. This hollow is, in a sense, the most truthful part of Holm 15A. It is where the galaxy's visible world recedes, giving way to the unseen. There are no dazzling cores of stars, no dense clusters to distract the eye, no whirling clouds of gas or dust. There is only the shape of influence, the imprint of a power that cannot be seen but can be felt everywhere. To observe the hollow is to witness gravity itself at work, its hand unmasked, its effect unfiltered by light or matter. Perhaps this is why the hollow feels so deeply symbolic. In its emptiness, it shows us presence. In its silence, it demonstrates strength. In its lack of stars, it speaks of mass, of weight, of a force that dwarfs all that surrounds it. In a universe dominated by luminous, flashy objects, blazing stars, radiant galaxies, brilliant explosions, Holm 15 reminds us that some of the most profound stories are written in quiet places, in regions where nothing shines. The hollow is a subtle teacher. It tells us that absence can be more revealing than presence, that emptiness can trace the outline of unimaginable mass, and that the invisible can be as significant as the visible. It is a whisper of the cosmic forces that govern the motions of everything, from the tiniest star to the galaxy itself. Yet, the hollow is only the shadow of something far greater. It is a map, not the territory. At the very centre lies the true origin of this extraordinary emptiness, the ultra-massive black hole. This central titan is heavier, more commanding and more fundamental than any star, cluster or gas cloud in the galaxy. The hollow is shaped by its influence, but the black hole itself is the source. To grasp why this black hole matters, why it is one of the heaviest, most silent and most historically significant black holes known, we must confront its presence directly, at the very heart of the galaxy, presence. At the very centre of Holm 15 lies an object so massive, so silent and so ancient that even the stars seem to tread lightly in its presence. It is not merely large, not merely extreme, but of a scale that pushes the very limits of what gravity can build in the universe we can observe. This is a supermassive black hole, a singularity so enormous that it defies ordinary human imagination. Its mass exceeds 20 billion times that of our Sun. To put that in perspective, it is a single object that outweighs entire galaxies. Its gravitational pull is so immense that if our own Sun were placed in orbit within its innermost regions, it would complete a full revolution in mere days, not the centuries that govern our planetary motions. And yet, for all this colossal weight, this black hole shines almost not at all. There are no brilliant halos of quasar light encircling it, no jets of energetic particles streaking outward, no glowing disk of matter spinning in a luminous dance around it. It exists in silence, invisible, except for the way its presence moulds the motions of stars and bends the paths of light that dare approach its gravitational dominion. In a universe bursting with luminous violent engines, Holm 15's central black hole is a paradox. It is the most powerful object in its galaxy, yet it is the least conspicuous. To understand it, one must abandon the intuitions we carry from everyday experience. A black hole is not a sphere in the sense we normally imagine. It is a region where the fabric of space itself has collapsed so completely that escape becomes impossible. For this black hole, the event horizon, the point beyond which nothing can return, spans billions of kilometers, wide enough to engulf every planet in our solar system in a single sweep. Yet, despite this unimaginable size, from 700 million light-years away, it is invisible. All observers can detect is the hollow at the galaxy's core, the subtle motions of stars dancing in its gravitational grip, and the faint distortions in space that reveal its presence only indirectly, as light curves around the massive centre. This black hole is more than a sum of its mass. It is the ultimate record of every merger and collision Holm 15 has ever endured. Each galaxy that spiraled inward, each smaller black hole that drifted to the centre, every gravitational encounter that flung stars outward at incredible speeds has contributed to its growth. It is the gravitational memory of billions of years of cosmic evolution. If the galaxy is a body, then this black hole is the scar left by all the catastrophes, encounters, and mergers that sculpted Holm 15 into what it is today. Its formation was not sudden. It grew over layers and epochs. It likely began as a seed, a black hole perhaps only a few 100,000 times the mass of the Sun in the earliest epochs of the universe. As the first clusters of galaxies formed, collisions became inevitable. Every merger brought in another black hole. When two black holes meet, they do not simply join, they dance. They spiral around one another, tightening their orbit through the complex interactions of gravity. This dance expels stars from the core, hollowing out the galaxy's centre. Eventually, as their final inspiral occurs, space-time itself ripples. Gravitational waves propagate across the cosmos, carrying away the final remnants of orbital energy, and the two black holes merge into one. Repeat this process dozens of times over billions of years, and the mass begins to approach that of Holm 15's central titan. What makes this black hole unique is not only its mass, but its stillness. Many ultra-massive black holes, especially those at the centres of early galaxies, manifest themselves as blazing quasars, devouring clouds of gas and radiating so brightly that they outshine entire galaxies. Holm 15's black hole, however, resides in a galaxy stripped bare. Gas no longer flows freely. The intracluster medium is too hot, and star-forming material has long been consumed or expelled. The black hole has eaten everything within its reach. It is not that the black hole has become weak. Rather, the universe around it no longer provides nourishment. In its dormancy, it transforms from a consumer into an anchor. Every star, Every fragment of matter, every passing cloud orbits according to its unyielding gravity. The hollow core is a map of its influence. The diffuse halo shows what escaped its grasp. The galaxy's very structure is built around the presence of this silent giant. Remove the black hole, an impossibility in reality, and Holm 15 would collapse inward. Stellar motions would lose their harmony, the gravitational balance would fracture, and the galaxy would no longer exist as we know it. This central darkness holds everything together. Yet, even as it anchors, the black hole also raises profound questions. Questions that push against the edges of cosmology. How large can black holes truly become? What controls or limits their growth? Do they halt naturally once they reach a certain scale? Or could the early universe have produced even larger quiet giants, hidden within clusters far beyond our observational reach? Holm 15 provides tantalizing hints but no firm answers. Its black hole exists at the boundary of theoretical possibility, a structure so massive that models of galaxy formation strain under its weight. Yet the models do not fail entirely. They adapt, bend, and reveal that in environments like Abel 85 with dense flows of infalling galaxies, such extreme outcomes are possible. Perhaps the most profound realization comes from contemplating the black hole's endurance. Objects like this may be the ultimate survivors of cosmic time. Long after the stars have cooled, long after galaxies have faded into ghostly remnants, long after the universe has expanded to the point where only local clusters are visible, these ultra-massive black holes will remain. They will outlast the light that gave birth to them. They will outlast the galaxies that formed around them. In the far distant future, when almost everything else has dissolved into darkness, these giants will persist, holding on to the last scattered remnants of matter. Holm 15's black hole is not merely a physical object. It is a monument to time, to gravitational inevitability, and to the remarkable fact that in a universe governed by expansion and entropy, some structures grow not by shining, but by quietly absorbing all that surrounds them. There is a kind of poetry here, though it is not human poetry. It is cosmic poetry, written in the trajectories of stars, in the very curvature of space. Holm 15's hollow core was not formed by emptiness but by motion, by interaction, by ejection. Its central black hole did not grow through radiance but through accumulation and silence. Its cluster environment preserved it not through protection, but through stripping, pressure, and the absence of new beginnings. Holm 15 is a story of how the universe sculpts giants. Perhaps this is why the galaxy resonates so deeply with us. It reminds us that creation is not always brilliant, that growth is not always visible, and that power is not always loud. In a cosmos shaped by collisions and collapse, sometimes the most extraordinary structures are those molded by quiet, relentless gravity over unimaginable spans of time. Holm 15 does not roar, it whispers. Its whisper stretches across hundreds of millions of light years, telling us that the universe is not only a realm of fire, but also a realm of shadows. Not only a place of beginnings, but also a realm of endings. Not only a home to light, but also to darkness, which itself has shape, structure, and story. As we step back from this chapter, from this journey into the heart of one of the universe's most massive black holes, it is worth remembering that we are still children of a young cosmos. Galaxies like Holm 15 are ancient, yet their stories are not complete. Their evolution continues quietly, in the subtle dance of stars, in the gentle curvature of space, and in the hollowed light at their centers. Somewhere deep within that hollow, behind a horizon we can never see, lies the object that shapes everything around it, the heart of darkness, the keeper of the galaxy's history, the silent titan that has endured for billions of years. Holm 15 is a testament to the slow, inexorable power of gravity, a force that builds without fanfare, that accumulates without spectacle, that shapes not with light, but with the invisible hand of pull and tug. The galaxy's hollow core, the stillness of its central black hole, the evacuated regions where stars once danced, all speak of a cosmos governed not only by explosions and brilliance, but also by silence, patience, and the steady pull of gravity over billions of years. From the earliest epochs, when the universe was still young, and galaxies were forming like islands in a vast cosmic sea, Holm 15's black hole began its long journey. Every infalling galaxy, every merging black hole, every scattering of stars contributed to its growth. Each event left an imprint, a scar, an addition to the gravitational edifice that now dominates the galaxy's heart. In this sense, the black hole is both ancient and eternal. It is a relic of the universe's youth, yet it is also a structure that will persist far into its old age, long after the fires of stars have dimmed, long after the light that created the cosmos has faded to memory. The core of Holm 15, hollow and quiet, is a direct reflection of this history. The stars that remain trace delicate paths dictated by the black hole's influence. Their orbits, often highly elongated, speak of past interactions, past slingshots, and past ejections. The very shape of the galaxy is the outcome of countless gravitational negotiations, each leaving behind subtle cues in the motions of stars, in the spread of gas, and in the curvature of space itself. Light bends, stars dance, and the galaxy persists, all because of the silent architect at its centre. As we contemplate this black hole, it becomes clear that it is more than a simple point of gravity. It is a chronicle of cosmic time, a ledger of collisions, and a monument to accumulation. Unlike stars, which burn brightly for a fraction of their lifetimes and then fade, or galaxies, which can change form over billions of years, this black hole is a constant, an enduring presence in a universe defined by change. It is the ultimate survivor, a structure that has not only endured but has grown, layer by layer, merger by merger, until it has reached a scale that challenges our understanding of physics. Holm 15's central black hole reminds us that not all cosmic power announces itself with light. Some exert influence quietly, invisibly, yet irreversibly. Some dominate not through spectacle, but through weight, persistence, and the patient accumulation of everything that comes near. In a universe obsessed with fireworks, with the brilliance of exploding stars, with the light of quasars and the blaze of active galaxies, Holm 15 whispers a different lesson. That time, gravity, and accumulation can create structures of unimaginable scale without ever needing to shine. Holm 15, with its hollow heart and its ancient still black hole, is a story of cosmic endurance, a story of gravitational dominance, a story of quiet power. The central black hole of Holm 15 is thus more than an object. It is a witness to the universe's history, a keeper of its secrets, and a monument to the power of accumulation over eons. It is the final word in a story of creation not as spectacle, but as persistence. It is a quiet titan, a silent monarch, a gravitational anchor around which an entire galaxy revolves. And as we imagine it, distant and invisible yet immense beyond comprehension, we are reminded that the universe's greatest structures are not always those that shine, but those that endure, shaping everything around them through the patient, invisible pull of gravity over billions and billions of years.